Hello everyone and welcome back to Simplilearn. In this session, we are going to understand generative AI for data analytics and how AI is changing the way analysts work with data. Consider a simple business question. Why did our revenue fall last month? Traditionally, an analyst might need to collect and clean the data, write SQL queries, compare the regions, build charts, and then explain the findings. With generative AI, the same analyst can simply ask, compare this month's revenue with the previous 3 months, identify which regions caused the decline, and highlight anything unusual. So this is one of the biggest changes AI is bringing to analytics. Instead of relying only on SQL, Python, formulas, filters, and dashboards, analysts can increasingly interact with data using natural language. So tools such as Power BI Copilot already allow users to ask questions, analyze the visuals, perform ad hoc analysis, and generate report summaries conversationally. AI adoption is also growing rapidly. According to McKinsey's State of AI 2025, 88% of respondents said their organizations were regularly using AI in at least one business function. OpenAI's enterprise research also found that 75% of surveyed workers reported improvements in the speed or quality of their work. Generative AI can now support almost the complete analytics workflow, from cleaning data and generating SQL or Python code to spotting unusual patterns, suggesting visualizations, summarizing trends, and explaining insights in simple business language. But AI-generated analysis is not automatically correct. Poor quality data, incorrect metrics, or misleading relationships can still produce incorrect conclusions. And that is why analytical thinking remains essential. The future of data analytics is not simply AI replacing analysts. It is analysts working with AI, using AI for faster execution while applying human judgment to ask the right questions, validate the results, and connect insights to real business problems. And throughout the session, we will see how generative AI is transforming the complete journey from raw data to useful business insights and better decision making. So in this course, we will explore generative AI and data analytics, that is, understand how Gen AI is changing traditional analytical workflows, traditional versus AI-powered analytics, compare conversational analysis with AI-assisted analysis, AI across the analytics lifecycle, and see where AI fits from raw data to business decisions. AI for data preparation and ETL. Understand how AI assists with cleaning, transformation, and data preparation. AI-powered exploratory data analysts explore how natural language interaction helps analysts investigate data sets, visualization, and data storytelling. Here, you will understand how AI helps communicate analytical findings more clearly. You will also look at AI-assisted data modeling, see how Gen AI supports SQL, Python, calculations, and modeling tasks. Forecasting with Gen AI, understand how AI can support predictive and scenario-based analysis. Real-world AI analytics tools, and explore where AI-powered analytics is already being used. You will also look at future of data analytics, understand how AI capability must work alongside analytical thinking and human judgment. So before we move on, let me share something exciting with you guys. If you want to build deeper job-ready skills in generative AI and agentic AI, check out Simplilearn's Advanced Executive Program in Applied Generative AI. This program covers LLMs, RAG, MCP, agentic AI, multi-agent systems, and LLM ops through practical learning. You will also gain hands-on experience with 29 plus AI tools such as LangChain, LangGraph, Crew AI, Claude, AutoGen, and Azure AI. You will also work on 10 real-world AI projects across areas such as technology, finance, healthcare, and banking. This program includes learning experiences with IITM Pravartak and Microsoft, along with industry-focused practical training. So if you're looking to move from simply using AI to actually building AI applications and intelligent agents, this program can help you take that next step. So before we get started, let me ask you a quick question. What should you do before trusting an AI-generated insight? A. Validate. B. Export. C. Format. And D. Publish. Let us know your answers in the comment section below. So now let's get started. Data analytics is ultimately about turning raw information into something useful for decision making. A company may collect information about sales, customers, marketing, campaigns, finance, inventory, products, employees, websites, or business operations. But simply collecting this information does not automatically create the value. The value appears when the data helps answer an important questions. Suppose a retailer wants to know, why did the revenue decrease this month? Traditionally, an analyst may first identify the correct data set, clean the information, calculate important metrics, compare the different periods, create visualization, and then interpret the findings. Generative AI adds another layer to this process. Instead of manually deciding every analytical operation, users can increasingly describe what they want to understand. For example, compare revenue across every region and identify 3 largest declines. AI may help translate that request into analytical steps. It could help generate SQL or Python code, calculate the metrics, summarize the results, or create an initial visualization. Microsoft's Power BI Copilot is one example of this shift because it allows users to interact with analytical data through natural language requests. So analytics itself is not disappearing. The important change is how analysts interact with the analytical process. Data analyst is becoming more conversational, faster, and increasingly AI assisted. Conversational analytics is already becoming part of everyday business operations. According to McKinsey's State of AI 2025, 88% of organizations use AI in at least one business function. OpenAI's enterprise research found that 75% of surveyed workers said AI improved the speed or quality of their work. Users also reported saving around 40 to 60 minutes per day with AI Assistant. This shows that AI is moving beyond experimentation into real-world workflows. The biggest shift is not just faster calculations but faster improvement from a business question to analytical action. In simple terms, AI is helping teams turn questions into insights much more quickly. So to understand the difference clearly, consider a simple business question. Why did the customer churn increase last quarter? In a traditional workflow, an analyst may first identify the relevant customer tables, then customer records, subscription history, support information, product usage, and cancellation data might need to be combined. After that, churn must be calculated. The analyst may compare customer groups based on location, subscription type, tenure, or usage. Several charts might be created before the actual cause becomes clear. Generative AI can assist during many of these stages. The analyst might ask AI to generate a SQL query for calculation churn. AI could create Python code to segment customers. It could explain an existing query, it may summarize patterns in the results, or suggest additional areas worth investigating. This can reduce a lot of repetitive analytical work. But AI assistance and analytical correctness are not the same thing. Suppose the organization defines churn as a customer being inactive for 60 days. If an AI-generated calculation uses 30 days, the result may be technically correct while answering the wrong business question. So the better workflow is human defines a problem, AI assists with execution, and human validates the result. The analyst ensures that the analysis remains meaningful. To understand the true impact of generative AI, we should not think of it as one separate analytics tool. We can place AI across the complete data analytics lifecycle. Everything starts with collecting data. Information may come from spreadsheets, databases, APIs, websites, business applications, sensors, customer platforms, or cloud systems. Next comes data preparation. The information must be cleaned, standardized, combined, and checked before meaningful analysis can begin. Then comes exploratory data analysis. This is where analysts examine trends, distributions, relationships, patterns, and unusual values. Depending on the business problem, they may then create calculations, statistical models, or predictive models. After that comes visualization. Insights need to be presented through charts, dashboards, reports, or KPIs. And finally comes the most important stage, that is decision making. Generative AI can support every part of this journey. During modeling, it can assist with SQL, Python, or DAX. During visualization, it can help create or explain the charts. And during communication, it can translate technical outputs into simpler business language. So generative AI is increasingly becoming one intelligent layer across the complete analytics lifecycle. Good analytics begin with good data. Real-world data sets are rarely perfect. They may be duplicate records. Dates may appear in different formats. Some value may be missing. Customer names may be written differently across systems. Numerical columns may accidentally contain the text. And information from different systems may need to be combined before analysis can begin. This is where the ETL becomes important. ETL stands for extract, transform, and load. First, data is extracted from one or more sources, then the information is transformed by cleaning, filtering, reshaping, combining, or standardizing it. Finally, the prepared data is loaded into a destination where it can be analyzed. Generative AI can assist with many of these activities. For example, an analyst may request, find duplicate customer IDs, standardize the date format, and identify rows where revenue is missing. AI may generate Python or SQL code to perform these operations. It can also explain existing transformation logic or suggest possible data cleaning steps. But AI still needs context. Suppose a missing revenue value represents a cancelled transaction rather than incomplete transaction. Automatically replacing that value could change the analysis. So the principle remains simple. Poor quality data plus powerful AI can still produce poor quality conclusions. AI can accelerate preparation, analysts still need to understand what the data actually represents. So once the data has been prepared, analysts normally move to exploratory data analysis or EDA. This is the stage where analysts begin investigating the dataset before making final conclusion. Suppose we have a sales data set. We may want to know which region generates the highest revenue, which products are declining, which customer group products are highest order value. Are there unusual transactions? Is there a relationship between discounts and profitability? Traditionally, analysts answer these questions using SQL, Python, spreadsheets, statistics, dashboards, and other analytical tools. Generative AI can make this process much more conversational. Instead of manually deciding every operation, the analyst could ask, show me the most important trends in this data set, or identify unusual values that should be investigated, or compare the profit margins across customer segments. AI can assist with calculations, generate code, suggest additional questions, or help explain the results. That allows analysts to explore more possibilities in less time. But interpretation remains important. If two variables move together, that does not automatically mean one caused the other. An unusual value may represent an error, but it could also represent an important business event. The analyst therefore needs to distinguish between a statistical pattern and a meaningful business insight. AI increases the speed of exploration. Human judgment determines whether the findings are useful. Finding an insight is only one part of the data analytics. The next challenge is communicating that insight clearly. A business leader usually does not want to inspect thousands of individual transaction records. Instead, that person may want simple answers. What is our revenue? Are we above or below target? Which region is performing best? Which product is declining? What requires immediate attention? Visualization help answer these questions. Charts make patterns easier to identify. KPIs highlight important measures. Dashboards bring several analytical views together. Generative AI adds another layer by helping explain what these visualizations mean. Suppose a dashboard allows the total revenue increase but overall profit decrease. AI could help generate an initial explanation by pointing the analyst towards possibilities such as higher discounts, increased costs, product mix, or regional performance. AI can also help summarize reports in natural language, but good data storytelling still requires human judgment. Adding 20 charts does not automatically create a better dashboard. The analyst still needs to determine which KPI matters most, which comparison should the audience see, what is the key takeaway, what action should follow. AI can help create and explain a visualization. The analyst provides a business meaning behind the visualization. As analytical problems become more advanced, analysts may need to create calculations, data models, or predictive models. In business intelligence, data modeling may involve connecting tables, defining relationships, creating measures, and calculating the business metrics. In data science, it may involve selecting variables, preparing features, choosing algorithms, training models, and evaluating the performance. Generative AI can assist with both. An analyst might ask, write a SQL query that calculates monthly revenue growth by region, or generate Python code for basic customer churn model, or explain what this calculation is doing. AI can create an initial solution and explain the logic behind it. This can reduce some of the technical friction involved in analytical work. However, generating code is very different from creating a reliable analytical model. The analyst still needs to determine whether the right variables are being used. The data must represent the real population. Data leakage must be avoided. The appropriate evaluation metric must be selected, and the model must answer the actual business problem. AI can help analysts experiment faster, but it should not remove the need to understand how the model works. So analysts may spend less time remembering every piece of syntax and more time deciding whether the analytical approach itself is correct. Traditional analytics often begin with understanding what happened in the past. Revenue decreased, customer churn increased, inventory fell, and one region missed its target. But business leaders usually want to go further. They want to ask what is likely to happen next. This is where forecasting becomes important. Organizations regularly forecast sales, demand, revenue, expenses, customer behavior, inventory requirements, and staffing needs. Traditionally, analysts may use statistical models, machine learning techniques, spreadsheet functions, or dedicated forecasting software. Generative AI can assist with this process. For example, an analyst could ask AI to generate code for a time series model, explain forecast results, identify assumptions, or suggest different forecasting approaches. AI can also support scenario analysis. Suppose expected demand is 50,000 units, management may ask what happens if demand increases by 15%, or how would inventory requirements change if demand increased while delivery times became longer. AI can help calculate and communicate these scenarios more quickly, but forecasts are estimates. Historical trends do not guarantee future outcomes. Pricing changes, competitor activity, economic conditions, seasonality, customer behavior, and unexpected events can all affect the results. The analyst determines how much confidence should be placed in that forecast. So where are these AI-powered analytics capabilities appearing today? One major area is business intelligence. Power BI Copilot allows users to interact with analytical data through natural language, ask questions, analyze visuals, and generate summaries. AI assistance is also becoming part of data engineering and data science workflows. Microsoft Fabric Copilot can assist with analyzing, transforming, debugging, and understanding data in notebook environments. General-purpose generative AI models can also assist with SQL queries, Python code, spreadsheet analysis, documentation, explanations, and recurring analytical tasks. These capabilities can be applied across almost every business function. A marketing analyst may compare campaign performance, a finance analyst might investigate unusual expense movements, a sales analyst could summarize customer performance, and an operation team might analyze inventory and demand. The important point is that generative AI is not creating a completely separate world of analytics. Instead, AI is increasingly being built into the tools and workflows analysts already use. The technology may change from one organization to other, but the overall process remains similar. Business question, data, AI assistance, validation, and decision. AI speeds up part of the journey. The business objective and the evidence still determine the final decision. So, what does the future of data analytics usually look like? It's unlikely to be a future where professionals simply stop learning analytics and ask AI to do everything. Instead, the analyst role is likely to move higher up the decision making process. AI can increasingly assist with repetitive analytical work such as generating queries, creating code, cleaning data sets, summarizing information, producing initial visualization, and identifying potential patterns. This can give analysts more time to focus on questions such as, is this data set reliable? Are we measuring the correct KPI? Why is this pattern happening? And what information might be missing? Or does this, I repeat, or does this conclusion make business sense? What decision should actually be made? These are not simply software questions. They are analytical thinking questions, and that distinction is important. So as AI tools become more capable, simply knowing how to operate software may not be enough. Analysts will increasingly need to understand the business, frame better questions, evaluate evidence, identify misleading conclusions, and communicate findings clearly. So the future analyst combines four strengths: business understanding plus data skills plus analytical thinking and AI capability. Generative AI can make analysis faster, more conversational, and more accessible. But humans still provide context, judgment, accountability, and decision making. And that combination is what turns raw information into reliable and actionable business insights.
Today, we're going to talk about generative AI use cases in the field of data analytics. As you all know, data analytics is a domain which is very helpful, especially making data science decisions and all. And since last 5 to 6 years, we are all hearing this term generative AI, where we want to leverage the generative AI technologies to make this data analytics domain more accessible and easier to work. So today we will be uh, talking about some of the case studies where will we see that how you can get some strategic insights using generative AI for data analytics. Just to understand the domain first, let us imagine that you are a chief experience officer of any multinational corporations, and where you have to, generate certain insights collected from different data, and that these insights will be helpful to take certain decisions for your company. So, as a chief experience officer, your role is to understand the patterns, trends, and maybe some kind of associations that exist within a data. And then basically you want to tell a story about these trends, these associations. Finally, ultimate objective is to convert these analysis into the decisions. In old days, we used to have some traditional methods to do that. We used to perform some statistical analysis, some graphical visualizations, and that help us to understand the pattern of data. But meanwhile, you discovered that some of your competitors are actually leveraging some of the advanced tools of GenAI, like ChatGPT or Microsoft Copilot or Anthropic Cloud. I believe you have heard all these terms. And these models are making the life of data analytics very easy, and they are actually, providing you a better data analytics, hidden pattern analysis, identifying trends and all, and then how you can use these tools into your organization. So today, in our discussions, we will be basically targeting to understand these kind of tools that help you to make data analytics field much easier and swift. Before that, you must have the doubt like what do we call this Gen AI? So let's first discuss on that Gen AI and then try to understand like how it is different from a conventional or traditional AI. So it will become very easy to understand the capabilities of these models and how you can use these models into different areas or different domains. Today we basically targeting this one of the domain called data analytics. So, before the Gen AI, we used to have AI, which we now call it as a traditional AI. And the objective of this AI is to automate systems. Now, when I say automate system, that means a machine can work without any human intervention. And for this, like we have to incorporate some kind of artificial intelligence into it. Now, this artificial intelligence help us to take certain decisions, especially when there is a situation of dilemma or when there is a situation of having multiple options. So these traditional AI were mainly being designed on a use case basis. For example, let's suppose we talk about a simple email filtration application or email filtering applications, where the objective of this application is to identify whether a particular email is a spam email or it is a not a spam email. So what we used to have is like we used to collect a data of certain emails where we can label these email based on their categories, whether it is a spam email or not a spam email. And then using this data, we used to train a model that understand like what is the pattern of a spam email and what is the pattern of not a spam email. So that model was good enough to understand the textual pattern to classify an email into a spam category and not spam category. And after this, like we use this model to make prediction for any new email. So let's suppose whenever you get a new email, you basically use this model to make a prediction that whether it is a spam email or not a spam email. If it predicts that the incoming email is a spam, then it forwarded it to a spam folder. Otherwise, it forwarded to an inbox folder. And that is how like we can simply automate the process of email filtering. Now, this feature has become one of the integral part of every email system nowadays. Like you must use Gmail and Yahoo, and now you are seeing that Gmail comes with a different kind of folders, like a promotional email or an inbox email or a spam email also. And according to the pattern of the email, that email is automatically forwarded to an appropriate folder, and that is what we call the automation of email filtration without human intervention. So the traditional AI, where we used to talk about these kind of applications, and when we talk about these models are pretty specific to the use cases. Like the model which is good enough to perform email classification is not good enough to tell whether it is a cat image or it is a dog image kind of. And this kind of AI systems were used to fall in the category of we call it as a narrow AI kind of system. So these models were domain specific, use case specific, and they can only be used for the use case where they were intended to train. But now thanks to this new technology which is coming into a market, like this is a GenAI, which is actually inspired from a concept of large language models which are trained on a very large corpus data. And when we talk about the capabilities of these models, like these models are capable of generating, data, and this data can be generated in variety of forms. Like you can expect to generate textual data, you can expect it to generate music, you can expect it to generate images, videos, etc., etc. And at the same time, because these models are really big enough and they were trained on a large corpus, so you can expect to perform different tasks using these models. All you need to instruct them correctly. And for me, it is very similar to that, like in old days, like 20 years back, where we used to write programs to perform tasks using computer. We can say like LLM is like a computer. All you need to write a right prompt to perform a specific task using that. So prompt is becoming a kind of program which can instruct this LLM to, do the job for you. And now these LLM are, capable to take different types of data. Like, so they can process textual data, they can process image data, video data, audio data, any type of data that can be processed by these models. And, you can instruct them to perform different tasks. So as I was saying, like this model is good enough to tell you whether a particular email is a spam email or not. At the same time, the same model is good enough to tell you whether the particular image is a cat image or a dog image. So now you can imagine that you have a model which is as good as a human intelligence level. So you can say that now we are matching the human intelligence level where you may expect that human can perform multiple types of tasks. Similarly, this model can perform multiple types of tasks. Now today we will be talking about data analytics, which is one of the very important domain of industry, and that is basically deals with analyzing data, identifying the insights, identifying the hidden patterns of the data, and then based on those patterns or based on these insights, this basically help us to take right decisions to run your businesses. Or in one word, you can say that data analytics is a way through which you can convert your raw data, into a information, into an information. And based on that information, you can actually take decisions. So that is something we will be exploring in today's talk. And so let's quickly go through with what are the learning objectives and what are the different kind of AI tools that we're going to talk today. So in today's talk, we will be first try to understand like how generative AI is empowering the businesses to analyze data and to help in decision makings. With that, we will also talk about some of the popular Gen AI based tools like Microsoft Copilot, Julius, and mostly through certain case studies. And there we will see that how the data analytics process is being run using these tools and how you can use these tools to get insights from a data. When we talk about data analytics, we always talk about statistics of data as well as some visualization in terms of some graphs and charts, So we talk about some dashboards where we draw these graphs and charts that help us to understand pattern of data. So we will also talk about these dashboards, and how GenAI tools can be used to create those dashboards and how they can support data-driven decision makings. And finally, we'll try to demonstrate the use of GenAI tool to streamline the complete data analysis workflow process that can actually increase your efficiency, the overall output of your the process. After this learning objectives, let's introduce generative AI for data analytics. Before going to that, we will first understand like what is data analytics and what are the objectives of data analytics into here. So as I said, like data analytics is a process that can convert your raw data into an information. And that information can also be referred as a valuable insights. Now, these valuable insights basically help you to make right decisions for your business, for your domain, anything like that. So as an overall process, basically there are three major objectives while performing data analytics activities. The very first is that it help you to reveal trends and insights from raw data. When you see a raw data, it is just a mix of some numbers, some categorical values, some dates, and different kind of the numbers and categories are presented into that. And when you read that into a tabular form, you might not able to get the information out of it. So when we say we are doing data analytics, we are basically trying to reveal certain trends or certain insights from that. Now, once you get these traits or insights from the raw data, this basically help us to take, smart decisions. So this process enables data-driven decision making, and this data-driven decision making is just because of that we are understanding the patterns and the trait. One of the simplest examples that we can say is that let us suppose you are collecting a data on a temperature and ice cream sale, ice cream sales. So let's say there are two parameters which you are collecting individually. You are actually recording the temperature on a day basis. At the same times, you are simply collecting the how much ice cream a particular shop is selling on that particular day. So you will start getting these numbers, and after some times you want to do certain analysis. And when you do the analysis, let us suppose you want to plot a simple visual chart between the temperature, considering it as an x-axis, and ice cream sale on y-axis. And you find like, on the basis of date, it is something look like to be this one. So every dot is representing a combination of number of ice cream sales on temperature on that particular day. And imagine like you see this kind of patterns to be exhibit with that data. Now, this particular graph is telling you that as the temperature is increasing, the sale is also increasing. Okay. So, like when we plot the data in the form of charts or in the form of graphs, certainly there kind of some pattern exhibit from it. And these pattern basically help us to analyze pattern and trait. So from this graph, we can easily say that there is a positive relationship between temperature and sales of an ice cream, where we can say if temperature is rising, the number of ice cream sales will be increasing. So that will help us to, keep the stock ready. That means now we can use this hidden pattern analysis to make better decisions. You should keep your stock ready if you are expecting that the temperature will rise in next coming days or next week. So this is how, you can make better data driven decisions into that. One very important thing while making these all system automated, which is the final objective of artificial intelligence, is that we also want to have a system that can integrate data from diverse sources. So maybe there is a unit which is recording, the temperature. There is a unit which is recording the number of sales of the ice cream, and now you want a system that can uniformly access this information and put them into a form where that can be used for the analysis. So this is what we call an integrated data from diverse sources for a comprehensive analysis. So with this simple, easy example, we can understand that how data analytics process are being carried out and how they can help us to make better data-driven decision processes. Now, when we talk about the overall process of data analytics, it has gone through with certain steps. So when we say data science, when we say data analytics, we always talk about a systematic study of unit. So if I'm saying like I'm going into a data analytics process, this process must to be a very systematic. So this has to go through with certain steps where each steps has its own clear objectives, and then you can reach to your final decision. So any data analytics process starts with identification of the problem. So in any domain, the very first thing is that we want to understand whether there is an opportunity to enhance the current state of the system, whether there is any gap in a technological gap, whether there is any problem in the system or so that. So, for example, let's suppose I am owning a company and I want to understand that what is the reason that people are leaving or people are moving from my country, my company or my organization to any other organization. And this is like where we call it as a churn pattern. So you all know, guys, what is churn? Are we good? Like, do we understand like what is churn? What do we call a churn? When a customer switches the services. So let's suppose there is an XYZ telecom service, and it is having a AB customer A, okay, who is taking these telecom services from XYZ. Now, after a few time, that A decided to move to any other telecom service company, let's say ABC. Now, when the customer shows this kind of behavior, this behavior is not as a churn. So this customer is churning its services to any other service provider. Okay, so let's suppose I am owning one service-based company, and I want to understand like if my clients are churning, what is the reason of that churn? So I first detect the problem, okay, and then I see the opportunity to improve with my business. So if I know that what is the reason that my clients are churning, I may provide better offers to them, or I may try to correct my mistakes or any kind of limitations which comes into my system, so I can actually stop this churning behavior of that customer. In that way, like I can enhance my business state and all this. So that is what, let us imagine like we talk about the churning. Now to do that, how I can detect this problem, and how can I try to solve this problem using data analytics? That's something we try to understand this with whole life cycle. So the very first step is to identify the problem, or you can say it's a problem definition. The next steps, what we do is we start collecting a data, because the data will tell you the story, and then you will get like what are the reasons that your customers are churning, or if they are not churning, why they are not churning, kind of thing. So the very next thing what you do is you start collecting the data, and these data can be collected on a variety of parameters. We call them features. So maybe you start collecting your data and based on the demographic of your customers, based on the age of the customers, based on the gender of the customers, based on the type of plans they are using, how many frequent call they are making, whether they are opting for a voicemail services or not, how many of them are making international calls. So you can collect a variety of data. And if you go to the broader domain, this data can even come from a different formats. Like the data can be in the text format, it can be a number format, it can be an image format, it can come through in any format. But the next thing is what you do is you start collecting a data. Now, when you collect this data, this the form of data is basically known as raw data. And raw data comes with a lot of inconsistencies into it. So maybe whenever you was recording that particular information, that field was not present. So you may see some missing values over there, you know. And when you was recording the data, maybe there was a typo error. So you may expect some kind of an odd value to be there. Maybe there is a column age and that has been filled with 110. So 110 is not an appropriate number for an age. So this is like where we talk about inconsistencies of the data. So the very next thing that we have to do is we have to clean the data. And when I say the clean the data, it is related to a data pre-processing where we convert our raw data into a most appropriate form to make this study, guys. So cleaning of data is basically related to handling missing values, handling inconsistencies of the data, removing of duplicacy, removing of some irrelevant information. These all kind of exercises what we do when we perform a cleaning process of the data. The next thing is what is analyzing the data. So once your data is ready, it has been cleaned, it has been removed with all kind of inconsistencies, then you start conducting a thorough analysis over that. And when we talk about the thorough analysis, this is where like we talk about the different kind of techniques that are used to perform analysis. Collectively, these techniques are known as exploratory data analysis. That techniques help us to understand the distribution of the data as well as the relationship of the data between variables and all. Ultimately, the objective is to identify hidden patterns or identify the insights from the data. Very soon, we will talk about these techniques and try to understand them. And once you have been, execute these techniques or once you have been execute these tools, so you as an output, you are getting certain graphs, certain charts, certain diagrams. And now you need to interpret these diagrams. So by interpreting these diagrams, you basically try to uncover the hidden patterns from the data, and then you use those insights to make better decision makings, guys. So these are the 5 steps that we generally followed whenever we talk about any data analytics process. So I believe like we are clear with this overall process of that. Now let me jump to the next thing. Like once we have understood the data analytics process, then let us see that how GenAI is playing its role into our data analytics process. So as I said, like GenAI is like where we talk about the artificial intelligence models which are capable to execute multiple tasks. All you need to prompt them correctly. Basically, when we talk about GenAI, we talk about LLMs, which stands for large language model. Or in short, we can say that we talk about the tools like ChatGPT, okay, tools like Cloud, tools like Gemini. And if you ask me, I think there are more than 20 lakhs large language models or the Gen AI models exist in today's AI world, guys. So, because these models are now surpassing the human intelligence level, that means we can use these models to perform different tasks if we can prompt them correctly. And that is something we're going to learn in today's discussion as well. So if let's suppose we try to execute a data analytics process, we have to look for any of these models, and these models comes with their own capabilities. But if you prompt them correctly, you can execute these tasks using these models. So now these models helping us to perform this data analytics process in more efficiently and timely manner, you can say that. So Gen AI is completely revolutionized the data analytics by offering a new way of uncovering the insights. Because as a human, we have our limitations and we can't think beyond this, beyond a certain limit. Similarly, we can't see the patterns after a certain limit. But can we think of automating this whole process? And that is the primary objective of AI. So the ultimate objective of AI is automating the processes. So can we actually can we think of automating this whole process or our data analytics process, like the collection of data to cleaning of the data, the analyzing of data, and finally giving you the interpretation of the data. So going forward, we will actually see the different way through which we can do all these kind of steps using GenAI tools. Okay, so at the end of the day, like what we expect, like GenAI tool generate new data pattern based on existing data. So let's suppose if you are limiting with number of data samples, can we do that? So this is one thing which we can do GenAI, because GenAI help you to generate new data points also. So sometimes, like whenever we talk about any domain, sometimes when we talk about any study, you lag with number of data points. But with the help of these GenAI tools, like you can expect to generate more, you know, data points that help you to make better analysis and all this. Now, it is an AI domain, so it can help you to automate all data processing tasks, which means imputation of missing values, removal of duplicate values, removal of inconsistent values into that without any manual intervention. And then it can also help you to identify trends and traditional, the insights or patterns within a data that can help you to do some predictive analytics and all this. So all these three things can be carried out by GenAI tools, and these three things are completely aligning with your data analytics process. So we will see them, one by one. So next thing is what once you know the pattern, and if you understand the pattern, you can use these pattern for making forecasting or predictions. And this forecasting and predictions can help you to make better decisions. One of the simplest example that we can see that, since the childhood, we have seen like whenever there are clouds in the sky, there is chance of rain. Okay. So what you see, you always look to the sky and see what is the pattern of sky, whether it is clean, or you can say whether it is sunny. Okay. It is partially cloud. It is cloudy. So you may see a different kind of patterns, and based on these patterns, you can make predictions. So let's say when you see a cloudy, you may predict that there is going to be a rain, and when there is going to be a rain, you can definitely look for an umbrella. I hope you're getting my point, guys. So now you understand how the pattern recognition help you to make prediction or forecasting, and that forecasting help you to make better decisions. I hope you are understanding the process, guys. So this is the very same thing we are talking about in a data analytics process, where like you collect our raw data. Okay, you clean our raw data, then you perform data analysis. Basically, you try to generate some trends, you generate some graphs that help you to do some pattern identification, some trend analysis and all this. Once you get the trend analysis, this will help you to make forecasting, or you can say a prediction. And when you have this prediction, that prediction can help you to make better decisions. So that is the overall process that we can think of making any system an automatic system, because decision is something that is being taken by human, by identifying that. But if you are very confident on your predictions, you can actually make these decisions automatic. You can simply make a rule based approach to make decision as well. So you're making your whole system automatic, and that is where we talk about the use of AI in any process. So here, like, we are going to use some Gen AI tools to do that, guys. So now, using Gen AI, we have understood the process of data analytics. But apart that, where we can think of use of Gen AI, so that is where like we talk about analysis of data. So analysis of data is not only used in decision making, but it can also be used some anomaly detection, and this is very important, especially in the field of finance, okay, or especially in the field of some risk analysis and all this. So anomaly detection is where like we try to talk about the data points which are not falling into the normal distribution or in the actual distribution of any data. Now, using a proper insights, using a proper analytics, we can easily find out these data points, and that help us to get the anomaly detection. One of the common example is like where we talk about credit card, and that is that is the duty of the banking systems to identify that whether a particular credit card transaction is a fraud or a genuine. And that is one of the use case that we can think of anomaly detection. So normally when you perform a credit card transactions, every user has its own demography, it has its own spending behavior or something like that. If any transaction which is triggered from his credit card not falling to its normal behavior from its own demography, that we can say that this is a point which is an anomaly point, and that can be used as a credit card fraud detection also. And similarly, like what happens, like when you generate these charts, when you generate these plots, like these points are clearly outside from your normal distribution. For example, if you talk about, let's say, two-dimensional data distributions where I say my amount is here, okay, and my demography is here. So let's suppose I mostly visited in three cities, A, B, and C, and my most number of transaction are in some, let's suppose, $1,000 or within $2,000 or $3,000, not more than that. Okay, so whenever I see my data distribution, I see my points are mostly be lying here, something like that. But suddenly you see that there is a transaction being triggered for some $5,000 and from some unknown city D. So that point is showing that particular point. So this point is considered to be a clear outlier for these points. So you can say like this is an anomaly point for this particular customer, and that's how you can use these data analytics approach to find out anomalies in data. Because any data which is not falling into the normal pattern of the data, or any data point which is outside of the distribution of the data, remaining data points is considered to be an outlier, and outliers are generally being considered as an anomaly. So that can be used for anomaly detection kind of thing. At the same time, and this is all possible when you start plotting the charts, when you start visualizing your data using some graph and charts kind of thing. And using that also, you can explore some hidden relationship. You can explore some inside trends from the data as well. So these are the major objectives of data analytics process, that where we see the role of GenAI, and very soon we will see some case studies also to do that. Thank you. So now let's see what are the basic challenges of data analytics when you do with a traditional approach, or like a manual way, what we used to do that, and where actually this Gen AI can help us to resolve these challenges. So I have listed them one by one, and very soon, like, we will see them a detailed description. The very first thing is a time consumption. And time is money nowadays. So when you talk about manual way of doing data analysis, it is very time consuming. Second, as I said, our human intelligence is also limited because we can't look after a certain threshold. So, if your data is really very complex and it has, deeper and deeper hidden patterns, sometimes you might not be able to, you know, get it done. And the next thing is, we are good at plotting charts. We are good at, visualizing the data into, into graphs and diagrams. But when you talk about the interpretation, we kind of get limited. Like, so we are not as good as interpreting those charts as we are good at, plotting them or visualizing them, because we know how to run the tool. But the next thing is that how to interpret that graph. Okay, so let's suppose if you get this type of graph histogram, or you get this type of histogram, what do you say? That's a simple one. And just to understand this, let me tell you, a simple examples to understand it, because this interpretation is very important, that how we do that. So let us suppose we have two data distribution, and when we say about a data distribution like A and B, we generally plot the distribution using a histogram. Do we understand what is histogram? Histogram is the frequency distribution of a numerical values. That's the simplest definition what we say. So let's suppose we have uh, two data distributions. One data is A, second data is B. Okay. Both data has the same mean. That means the average of the data set values of A and data set of values of B are same. So you can say the mean of A is almost equal to the mean of B. But the standard deviation of data point A is smaller than the standard deviation of data point B. So what I'm saying, the standard deviation of data point A is lesser than the standard deviation of data point B. Okay. The question is, how can I interpret that? So for that, let me give you two situations. The very first situation is, let's suppose this is showing the performance of a mutual fund. This is also showing a performance of another mutual fund. On an average, the NAV price is same. I hope you understand mutual fund and NAV prices, guys. Are we good with this terminology? So let's suppose you want to invest your money in any of the mutual fund and you have these two choices where you find that the average NAV price is same, but the variance in the first mutual fund NAV price is lesser than the variance of the second mutual fund. Now tell me which particular mutual fund will you choose and why? That's a simple question to ask us. Like when you have this high peak here, that means most of the values are conservative to this range, most of the values. If you see the histogram, that means this particular mutual fund is a low risk mutual fund, whereas this mutual fund will be a high risk mutual fund. Most of the time, it can go to be very low or it can go to be very high as well. Okay, so if you are a low risk investor, you should go with A. If you can afford to take risk, because high risk is high reward also, you should go with B. I hope I'm making myself clear, guys. That's how we tell the story using data. Okay. More variance means more range, more diversity. And when we say more diversity, that it can go onto the positive side as well as it can go to the negative side also. That means there is a lot risk involved into that mutual fund. So that is where we talk about data interpretation. So it is very easy to plot the charts, but how we can interpret that? And interpretation is completely depends on your perspective. Okay, so like you are telling the story, and this is up to the customer or this is up to the client how he will take that story. If I'm a low risk investor, I will choose A. If I can take risk, I will choose B. My role as a data analytics is to tell the story, like what data is telling to us. So I will say that, hey, we have two mutual fund A and mutual fund B. On an average, the net price of both the mutual fund are same, but the mutual fund A is less risky to invest because it has less variance or less deviation, but mutual B is more risk, comes with more risk to invest because it has a high variance into that. But when it has a higher variance, you have higher chance to gain more, but at the same times you have possibility to lose your money also. So that is what we basically talk about, the data story telling and data interpretation. And next is the data scalability. So this is the issue with, every system when the data is increasing and it is increasing day by day. If you ask me like the data, what we are curating in 1 second today, you know, that amount of data we used to curate in the whole year in 1990. So now you see the data is coming to a very high pace and it is increasing day by day. So whether your system is able to sustain that or not. So that's another thing. So there are certain challenges that we generally face when we talk about data analytics in a traditional way or in a manual way. But whenever we introduce GenAI into that, it is actually helping us to overcome all of these challenges. So what we can think of is like using a proper GenAI tool, the total time can be reduced by 60 to 80%. So when you perform data analytics, the overall process, acquiring the data, cleaning a data, analyzing the data, interpretation of the data, and the storytelling. The overall process, the overall time is actually being reduced by 60 to 80%. So you can imagine like with the traditional method, if you are taking 7 to 8 days, you know, to complete a study, to give the complete data analytics study on any domain, that can be reduced to even a job of one day kind of thing. So almost 60 to 80% time can be reduced by applying a proper GenAI tools into that process. Similarly, when we talk about traditional methods, we have to look these patterns manually, and sometimes we are not literate enough to analyze those patterns, because again, like it is being done by humans, and we learn and we actually grow with our experiences. So when we spend more time in doing these analysis, you become more and more proficient. But these models comes with proficiency. Already they are proficient enough. So these models save us to get better insights. These models can tell you better data interpretation stories to you guys. Uh, when you talk about interpretation, again, like the same thing, like the time taken to get the interpretation of one model and then writing the proper description for that, it takes around 1 to 2 hours. But that can be done by 15 to 20 minute data analysis. That again saving your 70 to 80% time with high quality. And data scalability is again an issue. Like you will store the data in either a relational database or in any data sources. Then you have to apply proper data injection pipeline that help you to draw the data from the source, and depending on the data size you take the tool to analysis for that. But these models are really large and they are good enough to work with a higher amount of data or a huge amount of data that can help you to do these analysis in a quick manner, guys. So now let me introduce some of the some of the Gen AI tools which we generally be used to do these data analytics. The very popularly we can talk about this Microsoft 365 Copilot. I hope you have been heard about this. You must have seen this symbol onto your the Microsoft applications like Word or Excel. If it is not available, you can actually add it and a plugin. So this is where like we can use, and the facility is that you can upload your data onto this Microsoft Copilot, and you can ask to summarize the report, generate the insights, even visualization. You can do it through that. This data robot AI cloud, it basically a tool which can automate the model building process, even the deployment process. So why I'm saying a model building? So like during the whole process, we talk about forecasting and prediction also, and that is where like we talk about these machine learning and deep learning models. At the end of the day, they are nothing but a prediction tools. Okay, so we need a complete automation where we can acquire the data, clean the data, pre-process the data, train a model, and then deploy the model. So this data robot AI cloud is one of the platform which can do it automatically. It's new kind of offering you can do with no coding, model deployment all. Another one is Julius AI. It's basically a powerful tool that simplifies the data analysis and visualization. And this is something we will be doing hands-on today. We will be doing hands-on today on 365 Copilot as well as Julius. And I think ChatGPT has been used by everyone, guys. And it's the most wonderful model. It is a large language model. It was basically trained to generate languages, text kind of data, but now it is being used for multi-purposes. Like you can use for data exploration, summarization, and even to get insights from the data by using an appropriate prompt. So prompt is like a program, guys. As I said, like in old days, like 20 years back, what we used to have a computer system which can do wonders. All you need to write a right program for that. And when you write a program, you can execute a specific task using this system. Now you can think this computer has been replaced by an LLM, which is a GenAI model. At the end of the day, it is a neural network model. And you can also expect to perform different tasks using this LLM. All you need to prompt it. Okay, so as you write program to perform task through computers, you can think of writing prompt to perform task using LLM. Okay, you just need to write a right prompt, and then we can expect to get the desired results out of it, guys. So when it talk about GenAI in data analytics, we can think of different use cases, different domains, and we can think of application of GenAI. For example, let's suppose we talk about logistics and delivery. It is especially related to your warehouse, inventory management, supply chain, and all. So these models can be used to make better forecastings, inventory forecasting, route optimization, um, and overall, when you have optimized route, you can reduce your transportation cost, you can reduce your total fuel cost. So this is where like we can think of application of Gen AI tools in logistic and delivery. When you talk about internet and web results, so the Gen AI is now using more smart algorithms to filter the content available on the web. So it try to give you the right set of data or right set of content for any query. Okay, it's like Google uses AI tools to provide you better results, domain and contextual results to you. Security is another domain where we can think of application of Gen AI, guys, especially in terms of anomaly detection, cyber attack pattern identification, and all these kind of things. One of the examples we have already discussed, like how we can identify the fraud transaction on any credit card transaction, and that is where we talk about anomaly detection and all. Media industry is like where we are popularly using all these tools. We are using these tools with like platforms like YouTube, platforms like Netflix, and we have very beautiful recommendation algorithms that personalize the content to a specific user based on his or her interest or preferences or watch history. So media industry is heavily using these tools to make better personalized recommendation to the end users. Coming to the healthcare, so again, like we are heavily using these tools in different areas like patient monitoring, drug discovery, curating the diet plans, analyzing the clinical notes, all these kind of use cases what we are using in healthcare domain. Then the risk detection is where we use these models like in chemical processing, manufacturing processing also. So, early fault detection in any machine. So these tools can be used over there. Then coming to the education, we can think of LLM as an assistant to any of the professor. It can help to prepare notebooks. It can help you to prepare questionnaires. It can help you to prepare, the set of examples for any particular topics. And at the same times, uh, the student or the learner can also be use these tools to have proper technical professional discussions with them. That is where it is always there to do the discussions, getting the answers of any topics and all these things. So the GenAI applications are not limited to these domains, but now we can use them to anywhere. As I was saying, and I'm still saying, like this GenAI model is actually equal to human level intelligence. So that means if whatever the task that you can expect to an average human, you can expect that to the GenAI on different domains, guys. Now let's quickly do a small quick check. Please tell me what you think. Like, what should be the answer of this question? What is the key challenges of the traditional method for creating reports? The very first option is the lack of automated tool. Uh, the next is connecting the dot across different report to understand the big picture. The third is high computational requirement, and the fourth is limited data availabilities. What do you think, guys? What should be the right option for this question? So the right option is B. So when we say the key challenges of creating reports, that means you have to connect the dots which are coming through a different report. So to understand the big picture. So maybe, the one graph is telling one story, second graph is telling second story, third is telling third story. What you need to do is you need to connect all these interpretation and then try to get the big picture, like what exactly you are getting at the end of it, guys. So this is like where we talk about the key challenge of traditional method, especially for creating the reports. But as I said, like is apart this, there are other challenges also related to the uh, time, related to identifying hidden pattern, handling the data scalability, or getting the right interpretation of the charts and graph. So now let's discuss about the GenAI in ETL or data pipelines. So as I said, like when we have seen the complete data analytics process, The very first thing is like we talk about problem definition, and then we talk about raw data collection. And like when we talk about this raw data collection, that can come through different processes, or that can come through a different sources. So the sources could be many. Now, if you want to automate the overall process, you also need to automate this step where you can collect data through different sources. Okay. And when you take that data to the study, you need to convert that into a uniform structure. That means you have to transform it, and then you have to load it to an appropriate place where it can be used by the next step for study or analysis or whatever it is. And that is what we call ETL, which stands for extract, transform, and load. When we say extract, that means the data should exist on different sources, and we need a uniform way to extract it. And then you have to transform into an uniform format, and then you have to load it to a place where it can be digested by the next unit. So this is where like we talk about data pipelines, and let's see how GenAI basically help us of doing this. So ETL stands for extract, transform, and load. Okay. The complete process involve extracting of data through different sources. Now, these sources could be your databases. Your sources could be your databases. Okay, so you can write a SQL query for that. Okay, or the source can be a simple cloud storage. The source can be an API request. The source can be a web page. So you may expect that data can be collected through different format, and every source has a different format of data. So that is what we call an extract way. The second is is the transform. So the data which is collected through these different formats may be structure or unstructured. So for like the data which is available in relational database is going to be an structured data where you may expect data to be represented into a tabular form. But when we talk about a cloud storage, maybe you are getting an image type of data in API. Let's suppose you are getting some JSON format of data in web page. Let's suppose you are getting some text pages of a data. So, these type of data, you can call it, these are an unstructured form of a data. Now, when you want to study the data, you need to transform them into an uniform format. And the most favorable format is that you have to convert this unstructured form of a data into an structured form of data, because it is easy to process, easy to manipulate, and easy to understand also. So generally what we do, we try to convert any unstructured form data into an structured form data. And this is where like we talk about different kind of data pre-processing techniques and all this kind of thing. So that is what is known as the transformation, and then we load this data into in a proper way, so it can be used by the next step tool or next step model for study or for analysis or something like that. So that is how we generally see the ETL process. And when you talk about the GenAI, like how GenAI helping here, so we have a way to perform all three operations collectively using GenAI tools. So GenAI is playing a very crucial role in performing these three steps of data pipeline. The very first is that it can help you to extract data from different sources. And when you extract this, actually you are posing that, but it can analyze the data source format and then help you to generate the appropriate format into that. So that help you to transform that. Very soon we will see that. And whenever we perform this transformation, we also perform some data pre-processing exercises like handling the missing values or cleaning it, removing all kind of inconsistency exist in data and all kind of that. And finally, like you can load it into an appropriate format. So if you want to have an Excel file or you want to have an CSV file, you can directly take the data to get it to be there, guys. So this is like where we see, and let us see one of the case study where we perform this ETL process using a GenAI based tool called Julius here. So are we ready to perform that case study, guys? I request you to please open your Google uh, search bar, and then please carry these steps with me one by one. Are we good? Do we have any question here? Okay, so what we will be going to do is we will be going to perform an automating the ETL process using Julius AI. So Julius AI is one of the GenAI tool that basically help you to perform the data pipeline activities in an efficient way. What you have to do is you have to go to the Google. Let me show you here. And then you just need to type Julius AI and just please click on the very first link over that. Okay, so this is the kind of page that you may expect. Okay, you may expect to land on a page. Let me let me go to its home page first, like this. I was doing some activity, so it is coming here. So you will be a page like here, this one. Okay, all you need to log in. So you can, sign up with your Gmail ID. That is also possible. You can sign up over there. The next thing is in your portal, there is a file available to you. So I request you to please first log into this and please come out to be this page. I'm pasting one of the URL link where our data set is available. Okay. You can see this dataset link over here. I have pasted that in our chat box, datausa.io. Unfortunately, this is showing this data is not available. Uh, but this is a URL link. Let's suppose the data is available over there. What you have to do is, are we ready, guys? Have you logged in on julius.ai? Can I get the confirmation, please? So once you logged in, guys, in a step two, what you have to do is you have to simply write a prompt. So your prompt should be, you can paste the URL link like this, okay? And you can simply prompt your Julius that use this URL to extract the data, transform it, and clean it. Sorry, transform it, clean it. So, like the complete data pipeline has three steps: extraction, transformation, and loading. So what you can simply prompt that use this URL to extract the data, transform the data, clean the data, and load it in CSV file. That's it. When you hit the enter, this tool automatically search for this particular URL location. And you see that it is writing a Python script that basically pull the data set available to this URL location. Okay. And if the data set is available, it try to pull it and then it try to load it, clean it, and convert that into a CSV format. So now you see that if you do not use this Julius AI tool, you have to write this Python script, that is where you required some coding skills, and then you have to do it manually. You means you have to first collect the raw data, then convert into a data frame, then, creating its column like that, and then make the data corrections in terms of missing values, inconsistency removal, duplication removal, and all this. And finally, you have to convert that into a output file called data USA population by nation.csv file. This currently it is I think giving us some API error, and the simple reason is like this file. I'm sorry, I was using an old script, so this file is not available. But I can give you another file for here. So let us see. We look for any platform. Let us say this data USA population data set. Let us see that if we found any other resources to that. This is one of the location where we are founding it, but unfortunately, let me use, okay, view aggregated data, download data. Okay, so now it is requiring a sign up. Let us use any other platform just to show you guys how it works. I'm just looking for a file to get available. This is also not the right. Okay, if I go with the census data, let us try the census GOV file, maybe that'll work. It will understand automatically. So what we will be going to do is we will be going to edit our message and we simply replace our URL to any other file. And I'm using a publicly available data, guys. Yeah. So you see it is again going with the same process of writing a Python script to pull the data from the source. And then it try to run that code. And you can see the data set is now being fetched. And this is where it is being generated, guys. CSV file. So you see, it is that simple when you use a GenAI tool to perform your ETL process. It is that simple. You just need to uh, give your data. So that is a clean CSV file that you can think of. Julius file is verified that exists. Uh, you can simply think of loading that file. I'm loading it file and you see this is the census data which has been loaded. Simple one with the locations, guys. So when it comes to use any such tool, you just need to prompt it correctly. So, like what we are doing here, we are prompting it, and this is what we call a prompt. We are giving the source of data, and then we simply instructing the model to use this URL to extract data, transform it, clean it, and load it in CSV file. That is where we work. So this is where we can think of, automating the ETL process using Julius AI. Julius AI is one of the GenAI tool. There are other tools are also available. We are going with Julius. Okay. Then I have a very simple question to you guys. Let's suppose if you are not using uh, any GenAI tool, how would you know that your data has any missing value in it or not? Let's suppose you are representing that data into a data frame. How would you know that your data has any missing values? What is the way of knowing it? So normally the missing values in data are represented by NaN. Always remember, not a number. So we look for those values. We can simply make the count for that, guys. Yeah. Okay. So now let us look for the next thing. So this is where like we have understood like how we can use GenAI tool to automate ETL process or data pipeline process. So overall, it looked like to be, this one, like you have a different sources, you can collect the data, then perform some pre-processing and load. So that basically gave an efficient data management pipeline for that. So data pipeline is now being augmented with some other aspect also. The first is we have seen like it is automating code generation. Okay. That is something you have experienced while playing with that Julius AI. So it was automatically generating the code to pull the data. Then it help you to simplifying the data mappings. So from the past examples, it is suggesting the transformation and then it is streamlining the whole process. Like what are the different columns, how you should align these columns. So this is all being coded. And finally, like it can also enhance the data quality by spotting any kind of inconsistencies that exist in the data. And that is where like you try to clean up the overall process, guys. So that's what we say that GenAI can play a crucial role in each stage of data pipeline. And all these three steps can be automated by simple one prompt. That's something we have seen. When we talk about real-time data integration and analysis using pipeline, there are some standard steps what we basically carried out into that. So, we start with cleaning and enriching a data. That is something I think we have already cleared it about. Whenever we collect a raw data, the raw data always comes with certain inconsistencies into it. Maybe there are some duplicate values, there are some missing values, there are some odd values may present in the data. So what is you need to clean it that. And sometimes like we talk about enriching. So enriching is like when you try to impute missing values, when you try to remove outliers, when you transform your data from one form to another. This is something what we call enrichment of data. And the next thing is identifying and connecting the sources. That means the data can come through different portions. As you see, like we have simply gave a one URL, but it has to figure it out like what is the actual API to be hit to get the data. And like in the very first try, we were not able to get the answers. The reason is like we were not able to hit the API, so we were getting some status error over there. So your tool has to identify and then it has to connect the sources. And then we basically talk about moving data into a real time. So this data has been pulled, and finally we can think of extracting, you know, the insights from that. So in the real time, when you try to make the overall system in a real time, you have to perform all these tasks, you know, in the real time, like in whenever you hit or whenever you trigger the process, it has to be executed in real time. The benefit, I think, we have seen it. The overall benefits are it enhance the decision making, because when you get the right insights, when you get the right information about your system, about your domain, you can take better decision. So it can definitely enhance your decision making. It improved your operational efficiency, because now you can do the job of weeks in days. That is something we have seen, like with the use of these GenAI tools, we can literally save almost 80 to 90% times of overall data analytics process. And secondly, these systems are pretty much adaptable, and that is very easy, because if you draw one pipeline that can accept one format of data, and suddenly the format of data has changed, you need to update your code, you need to change your whole pipelines. But these tools are capable enough to adopt these changes in a very quick way. So the adaptability is one of the another features of these tools. So by incorporating Gen AI in real-time data integration analysis can enhance on every aspect of the process. Now let's say a quick recap. What is we say that how can GenAI enhance the ETL process for data pipeline? By manually cleaning data before loading, by suggesting data transformation and automating code generation, by reducing the need for data extraction, or by eliminating the need of data warehouses. Guys, what do you think? What is the right option? And I guess B is the right option, because by suggesting the data transformation and automating the code generation, these tools really help us to enhance the overall ETL process of data pipeline. Now let's talk about another aspect of data analytics, where we talk about data augmentation and synthetic data generation. So when we perform data analysis, you guys, this is very important to have sufficient amount of data points, because if you have small samples, the the interpretations or the conclusions that you provide may not be correct. Okay, so you always try to get a large sample or a more data points. But in some use cases or some fields, these points are not readily available. They are not available, maybe due to time or maybe due to the cost to acquire these points. So what another way is used there is, can we augment the data or can we generate synthetic data from the same distribution? And that is where we can upsample your data points basically. So if you come up with, let's suppose, 100 samples of data points, by using data augmentation or generating synthetic data, you can convert these 100 to 200 samples or to some 500 samples to make the study valid. Now, data augmentation is different from synthetic data, where synthetic data, we curate the data from scratch. So there is no available data point exist. But in data augmentations, you have some sample data points, and using that, you can create more sample data points. That is what we call a data augmentation. And both the techniques are popularly be used in data analytics process, but these are completely vary domain to domain. The most preferable technique is data augmentation as compared to synthetic data, because data augmentation is talk about generating more samples of the data from existing sample data points like that. So let us try to understand these two steps and try to get the characteristics of each of them one by one. So as I said, data augmentation, it is a data analysis techniques, and this is basically used to generate examples from existing data, which means that you have already a small sample of data, and with the help of that, you want to generate more data samples, kind of thing. For example, let's suppose you have a variable X. For that, you have certain data points like this. And now if I say that augment this particular data, so currently you have, let's say, 4 and 7 data points. You want to make it 15. So that is you want to have some 15 data points into that. But how it can be done? So augmentation is very important. When we perform the augmentation, we want that the new sample must align with the distribution of previous sample. So it is not like that you can randomly populate some data points. It's not like that. What we expect that the new sample distribution must align with the previous data sample distributions. So when we talk about the distribution of data, we basically talk about the two important statistical parameters called mean and variance, or you can call it as a standard deviation. So whatever the mean and standard deviation that is for this 7 data points, we expect the new data point also come with the same mean and standard deviation. Then only we say that the samples are same, and the only difference is the number of data points to that. So there are techniques which help us to do that, and there we can use GenAI models, like they can understand the distribution of the data and then help you to generate more examples from existing data. That is one what we call data augmentation. Now, when we do this, this help you to increase model diversity and complexity, because if you have more data points, you can expect to create more diverse model with more complexity. And sometimes it can also be used for class representation to reduce the biases. And this is very important, especially in case of the finance sector or health sector. So what is this balanced class means that? So like in the philosophy of machine learning, we collect data, and this collected data is used to train the model, guys. Let us imagine you are trying to train a model for a cancer prediction. So there is a model that you want to uh, use to make cancer prediction correctly. Now, the data set, what we generally see in health domain are mostly imbalanced data. Mostly imbalanced data. And that imbalance means that if you collect a data sample for 1,000 patients, you find that out of 1,000, 100 are cancerous and 900 are non-cancerous. That's the general pattern what we see, like when we talk about the cancer data. Like out of 1,000, you find like 900 are non-cancerous and only 100 are cancerous. Now, in such cases, when you use such data to train your model become more biased towards a non-cancerous prediction. The reason is very simple, because it is seeing more examples from this category. So it learns that pattern more as compared to the other pattern. And this situation is called class imbalance. This situation is known as class imbalance. And that introduce bias in your model, because the model was seeing more examples from the one category as compared to the another category. So it become more favorable to the majority category, where you see the most number of examples. So augmentation is generally used to make it balance. So what we do in augmentation, we try to add more sample points, data points from the minority class or from the cancer class. So the proportion of the categories become more or less same. So maybe it is like, if this is 900, maybe you can add another 600. So that becomes 700 for cancerous. And the total data points are become now 1,600 or so. So this is what one of the use case of data augmentation, which is basically used to balances the class representation and that help us to reduce the biases. I hope you have understood this line, guys. Are we clear with that? So that is where we talk about data augmentation, which is where we try to generate more examples. Okay. So first of all, we should understand like what is data imbalance and then how data augmentation can help us to do that. So data augmentation is a techniques which can generate more examples from existing data. That's a simple one. Let us imagine you have been given with a simple data set which have two features or one target variable. Let's suppose the values are 2, 3 when the target variable is true. When the values are 4, 5, the target value is 5. 5, 6, the target value is 5. 7, 8, target 5. 9, 3, 9, 6, target is 5. Okay, 7, 8, target is false. 2, 1, target is true. Now you see, when you see these values, you see most of these values are from false category. So if I say only this y variable, 1, 2, 3, 4, 5, 6, 7, out of 7, 5 are from false category and 2 are from true category. Can I say that this particular data has imbalance with respect to the categories of y? Out of 7 samples, 5 samples are from false category or only 2 samples are from true category. Can I say that data has imbalance? Now let us suppose if I use this data to train my model. Let us suppose I use this data to train my model. Since the model is seeing more examples from the false category, so it become little bit biased towards that. So it will make better predictions for false category as compared to true category because it has seen more examples from that category. It is very similar to that. Let's suppose I am a teacher and I have a class of students. And when I teach the concept of plus and minus, I use 10 examples to teach plus and only 2 examples to teach minus. What do you think? My student will be good at performing pluses or minuses? What do you think? Pluses. Because my training example has more examples from the plus side or addition side. So these learners become biased towards the majority data points pattern. Okay. So to reduce this bias, what I have to do, I have to incorporate more training examples from the minority category. But these examples are not available. So I have to augment them. I have to augment them. That means I have to generate more examples from existing data. So this is my existing data. Using this, I see where is the distribution of true class. So you see there is a pattern that false categories are having high values from x1, x2, but true categories are having lower values from x1, x2. So I can use, like 1, 3 for true, 3, 4 for true, 4, 2 for true, 1, 3 for true kind of thing, or 4, 3 for true. So by understanding the distribution of minority category from the existing examples, I can add some dummy data points. And these dummy data points are basically the augmented points, but they are not random. They are actually being created by studying the existing data point pattern first. So now you see that when I added these 4 examples more, so finally I am having 6 examples from true category and 6 examples from false category. And now with these 12 examples, when I train my model will have equal bias towards plus or minus, or you can say both category true and false. So this is what we call our data augmentation. And now we will see, one of the case study that help us to understand that how we can perform the data augmentation using GenAI tool. So here we will be going to use ChatGPT 4. Okay, so you all have used ChatGPT in your life, guys. You have used it for writing your cover letters, getting the knowledge, informations from it. You have done this many times. Let me use it for data augmentation. So again, I will request you to please download this one of the data set available on our LMS. This is a credit card data. And if you see this credit card data, it is very clear that this data has columns like card number, card holder name, expiry date, CV, the amount, and the currency. Okay. If I look for this data and different kind of values here, if I apply filter, you see that the card number is going to be a unique value. So there are different card numbers are given here. If I talk about the card holder name, this is also a unique value, or a one person can hold many card also. If you talk about expiry, so this comes in different years, that current value, something like that. The amount is also being ranged. When you talk about currency, then we have a different currency available for these cards. So this is what our data. And when you talk about the total number of samples in data, you can say it's 1,000 samples are given here. Can you see that? Can I say there are total 1,000 samples are available, right? So what we gonna do is we going to augment this data to generate more data samples, guys. And for doing this, we will be using one of the GenAI tool. GenAI tool means the tool like ChatGPT, the tool like Cloud.A, the tool like Gemini. You can use any tool. We will be going to use our ChatGPT. Browser once again. Again, go to the Google and try to type ChatGPT here. So it will actually take you towards a ChatGPT page. You can directly click on this. That will take you to this page. I'm already logged in. So you can see. The very next thing is what you can think is you can first download your data set from the LMS. Please download that data set from LMS. So now when you have downloaded this, the very next thing is what you have to do is you have to upload this data onto your ChatGPT. So to get it uploaded, you can simply click on this plus button. When you add it on plus button, you will get these many options, from where you can add photos and files. So the next thing is what you'll need to click on this add photos and files. And from this, I think you can go here and this is your data set. You simply click on upload. So that file is being uploaded to the ChatGPT platform. So are we good here? Like, are we, able to compile these two steps, like downloading the data and then uploading the data on ChatGPT? Now, once you do that, so, like what you have to do is you have to augment your data. So when I say augmentation, that means you have to add more more data samples using existing data samples. And for doing this, you need to write instructions for that. So what you can do is you can simply write a prompt that increase the robustness and diversity of the data set by generating augmented data. So when I say the augmented data, that means we are trying to add more data samples into the existing data. But when you add this, what you expect? You add instruction that mirrors the characteristics of given data set. That's simple. You just need to add this one, characteristics of given data set. You can write that mirror the distribution of current data set. You can write that align with the distribution of existing data set. But when you hit this prompt, the chat GTP start, forming this, and it is going to, add more training samples. So what it is doing, it is generating new valid length card number. It is actually adding some card holder names from faker library. That is means it is going to add some fake names into that. Now it is adding some expiry date. in the format of month and year. Then it is adding some CBB value. Okay, then it is also adding amounts to that. And finally, it is adding, some currency like US dollar, euro, INR kind of thing. Now it has generated like 2000 plus. So you can simply say that, yeah, generate an augmented data set and save that CSV format. Just type the next thing. So when you do that, it is basically try to curate more data points, and it will provide you a link from which you can download that CSV file. So it is analyzing it. And now you see that you are ready to download this file, guys. When you download it, the last time you have seen only the 1,000 data points were there, but now you see the total data points are being extended to even 3,000. So it has added 2,000 more data points into that, and they are all being filled beautifully. So this is like where we can think of augmenting a data, which means generating more examples from existing data points. And this is again like we are using a GenAI tool to execute this process, the data augmentation. So that's where it helps us to do that. Going forward, there are tools which can even generate synthetic data. And synthetic data is basically a process that creates new data as a substitute of real world data. So we don't have any existing data points, but still we want to curate more data points out of them. So there are some basic difference between, I must say, the augmentation and synthetic data. Okay, so data augmentation is where you try to create more data points by modifying the existing data points. Okay, so so I hope you have understood, Samala, what is data augmentation. Data augmentation is where you try to add more training examples using existing training data. So let us suppose you have some existing examples. For example, let us see that I have this example. Um, Please augment below set of data considering the distribution. Let's suppose we have been given some data points 2, 4, 5, 1, 6, 3, 5, 9. So originally, let's suppose you have this sample of data where you have around 9 data points 2, 4, 5, 6, 3. Okay. What we want to augment the below set of data considering the distribution. Please, or you can simply instruct extend it to have 20 data points. That's it. So what ChatGPT is doing, ChatGPT is first analyzing that what is the distribution of this data. When we say the distribution of this data, it try to find out what should be the mean and what should be the variance of these data points, guys. Got it? And now by understanding that, it is trying to add more sample data points. But when it is adding more sample data points, it is considering the original distribution of the data point. That means the original distribution of data in terms of mean and variance should not be disturbed. Okay, so now the total number of samples have been increased from 9 to 20. So it has added some new data points. So originally we have 2, 4, 5, 6, 3, 5, 7, 9. 2, 4, 5, 1, 6, 3, 5, 7, 9. These data points are being added extra by using data augmentation. Exactly the same process we carried out with the CSV file, where we have uploaded the CSV file with some 1,000 data point into it. And then we augmented the ChatGPT to add more data points to make it 3,000. So by studying the distribution or the characteristics of original data, it is actually adding some dummy data points into that sample. So, like it has card numbers, it is adding some dummy card numbers, but it is following the structure and formats. So it's not generating any random card number. It is actually generating a valid new card number of 16 to 15 digit. Holder names, it is not generating any dummy name. So when you look, when you look that particular data, you will not see that these names are some XYZ kind of names. You see these names looks to be real names because these are generated by Faker library. Can you see that? These are not any dummy names that we are giving. So it's not like ABC, XYZ, what we are following here. I hope you are understanding that. Are we clear? Yeah. So this is how like we can use GenAI tool to make it possible. Coming to the basic difference between augmentation and synthetic is the one, the one is that the data augmentation is done over existing data points. So we have, the new data points are aligned to the distribution of the existing data points, but synthetic data is generated entirely from scratch. So we tell about the characteristics of the data, and this is being generated from scratch kind of thing. When it talks about close to the reality, so data augmentation basically generated based on the inheritance characteristics of existing data points. It is more closer to the reality. Uh, it offers the high realism, but not similar to the augmented generator. Uh, in terms of the complexity, it is simpler to generate because you already have the existing data, you know the characteristics of the data, you can easily generate that. But synthetic data is complex to generate because that has to align with your real data distribution and all kind of. When it comes to the biasness, and I hope now we are good with the biasness, like if data has any imbalance, then it will have the imbalance kind of thing. So because the data augmentation is purely based on the existing data characteristics, so it inherit the biases. But synthetic data offer greater control over biases because in that way you can generate better data generations and all guys. So these are the major areas where we can think like Gen AI try to benefit data augmentation. It basically filling the data gaps, it protecting the privacy. So in some of the use cases, people don't want to reveal their private information. So in that case, we can use data augmentations to, add some dummy name, anonymize and kind of thing. It can help you to balancing the data set. I think we have already, seen this. So if your data has imbalance, we can apply data augmentations to balance it out. It help you to saving the cost because the data collection is a very costly domain, and you have to invest a lot of time and a lot of money to collect the data from different sources and all this. It's not that easy that you go to a website and simply download that. When you try to collect the real data, you have to collect this data using some surveys and hitting different domain and areas and all this. uh, Another aspect, what we see from model side, if you have more data points, you can train better models. So that help you to improve the model. It can help you to do better testing and training, and even it help you to boost innovation. So in some of the domains, the data is not available, but if you can use synthetic data, at least you can start off thinking to getting a benchmark model development kind of thing, guys. So we were discussing about data augmentation and synthetic data creation. So let's talk about another GenAI tool which help you to generate synthetic data. And it basically create realistic synthetic data for different AI projects where there is not enough real data is available. And one of the best part of this tool is it maintain the privacy and enhance AI performance. So whenever we curate these data, privacy is a big concern. People are not ready to, share their private information, demographic information, their name, personal identification numbers, and all these parameters. So this particular tool will help you to, get it done. And it can generate a good amount of synthetic data, which you can use to train your AI models and use for different purposes. So let's quickly see that as well. So again, you need to go on to the mostly.ai platform and you have to sign up. So I have already signed up. So this is where like you can see that I've logged in with my Gmail ID. And when you logged in, you will be at this particular page. You must be seeing this kind of interface onto this mostly. Once you are ready, please let me know, and then I'll walk you through with the next steps, like what we have to do while we create a synthetic data using mostly.ai, guys. all you need to have is you need to download one more data set. Okay, and that data is a retail sales data. It's a very small amount of data set. It has only 20 data samples. As you can see that you have been given with different columns like date, the name of the product, the category of the product, sales of the product, quantity, in which region this particular product is available, and which store is available, and what is the customer segment, like whether it is a high income segment, low income segment, or a mid income segment. And here we are being given with some 20 data samples, and our objective is to generate more synthetic data so we can leverage this data to uh, train our AI models or use it in different purposes, guys. So what we do is the very first thing is, we have to log into this mostly.ai page, and this is where you get a page like this. The next thing is as you are going to generate the data, so you can click on this particular tab and see like where it is taking to you. So it is where like we are going to, generate the data, and it is telling you like how we can, what kind of processes that it can be used. The very first thing is like, you can create a quick mock data. What kind of data is that you want to be generate? So to do that, you can always think of upload a file. So let me upload a file that is a retail sales.csv file, which I have. And very similar to the other process where we have uploaded a file to perform a data augmentation, we kind of, trying to upload that file. So once this file is actually being uploaded, you can simply, what you can say that prompt it like that. And when you prompt it, we, you know, uh, can think of what you say, either switch to generate a Python code as an input, or you can simply, enter a kind of instructions that we have seen to generate others. Uh, but using this, we can also look for other parameters that can help you to generate synthetic data sets. So if I go here, and if I try to get the different options like generating mock data and browse generator kind of things. So here, like there are some readily available data sets which you can use for that, guys. And then you can define a new generator as well. And this is something we were into. We were actually generating a mock data. So I'm again going with the same step, upload a file, and then, you know, we can simply first, uh, you can simply prompt it like that. Try to see that. And that's the very first thing that we try to see that. Generate synthetic data for 1000 sample points. Let us say that. Try to do this. So first it is actually loading and analyzing the retail sales data. It's a very same process what we have seen on, the previous ChatGPT environment. And now it is trying to generate some 10,000 synthetic retail sales records. And if you see, and if you read it, it is also using a GPT-4 nano model at the back end to generate these rows, guys. That is the one way that you can use a simple, the prompting. Another way is like where you actually try to generate a synthetic data by training a model, and that is where like we talk about the trainer generator. And here you can upload your data. So all you have to go is you have to click on this generator section. And when you click on this generator sections, you get these two options. One is train a generator on a platform or locally. That means you are trying to train a model which can help you to generate synthetic data. The synthetic data which is going to follow the characteristics of your uploaded data kind of thing. So let's say if you want to generate a data of of any type, we can think of loading a CSV file. So I can simply drag and drop here, click on the proceed. So this particular data set will be uploaded over there. And once it is uploaded, then we can think of you know setting certain parameters. So when I say setting certain parameters, like here you see that we are talking about data configurations. Okay, so if data configurations, that means we can now start configuring the model. So you can simply click on this particular option, and from there, you start looking the configuration of the model. Now, this is where you're talking about the available data, where you can actually configure your model, like how it is going to be generated. So when you click on this retail sales, you see what kind of models it is using, what kind of compute resource it is using over the platform. Then you can set certain training parameters. It is like you are trying to get the model parameters and all. So it's like maximum training time, maximum samples that you are looking for. So I would say that I'm looking for like maximum sample size of 200 rows, maximum training epochs. This is again like we are looking for training a model. So that's something you can set to a by default 10. Physical batch size or gradient accumulation, it can also be set to be, some default values. Then if you talk about differential privacy, and this is, I said one of the major feature of this mostly that it can generate anonymous data. So you can actually set it to on or off kind of thing. So when you use on, that means it uses differential privacy when you need mathematical guarantee of privacy and that. So it's kind of suppress any personal identification entity kind of thing. Although in our data, we don't have such field. Okay, so we can keep it to like that. And there are other parameters also that enable flexible generation, value proportions, and if you want to generate your model reports and all these things. So after setting these all the parameters, what you can do is you can start training. And when you see that this training is being started, so what is it doing? It is fetching the training data. That means the data what you have uploaded. Then it start analyzing the training data. Then it start encoding the training data, which means it try to suppress the any PII information and that. And after that, it try to train an AI model that help you to generate such synthetic data based on the given data training process and all. And once all these processes are being complete, you can see like this kind of model samples is being generated over here. So these are some of the points that you can see are being generated. And finally, we can download all the logs to get the configurations and all these things. So this step is mostly being processed or used when you have more understanding about synthetic. Otherwise, you can go with a very simple approach is uploading and prompting it like just create a synthetic data, guys. So this is about what you can say synthetic data generation and data augmentation. Now let's talk about the next step, which we talk about data integrity and other aspect of the data, guys. So data integrity, what do you understand by data integrity? Simple way. Okay, so data integrity basically refers to maintain the consistency and completeness of the data. So whenever you process the data, it should not be disturbed. It should not lose its consistency. The noise must not be introduced into the data. That is what we call a data integrity. So whenever we perform any kind of data analytics, we expect that this integrity parameter must be possessed by your system in overall automation process, guys. So let me quickly, take it to the, what do you say, full screen. So why it is important? Because it is very vital at every stage. So if you say that your data become corrupted, or there is some noises introduced into the data, or there's some inconsistency introduced as data, The final model that will be generated by the data will not be the accurate model. So it is very important to ensure the data integrity in the overall process, guys. Now, how GenAI help you to maintain this data integrity is again like, so GenAI tools can be used to validate data against predefined rules or patterns. So you can actually use these tools to analyze your data, and then these tools can help you to tell whether the data integrity has been preserved during the process or it actually being disturbed, or basically the quality of data is being disturbed and all. So when it comes to deliver the data based on certain quality standards, it is very important to keep on considering this data integrity parameters, guys. Now let's have a quick check of what we discussed till now. So what is the significant advantage of using GenAI for data augmentation? The very first is eliminates the need of real data. Uh, it generates synthetic data to fill data gaps with balanced data set. It reduces the size of data set. It only works with the structured data, guys. That's right. So it basically help you to generate synthetic data to fill data gaps and balance data sets. That's right. The right option is the option B. Now let's talk about exploratory data analysis with GenAI. So first of all, we should understand like what is the exploratory data analysis, and then we'll talk about the tools that help you to get it done. Now the primary objective of exploratory data analysis is to analyze and identify the distribution, pattern, trends, or association within data, guys. So that is what the overall objective of exploratory data analysis. It is mainly of two types. The very first type data analysis, we call it as a univariate analysis. We call it as a univariate data analysis. When we say univariate data analysis, that means we consider one variable at a time. So we can talk about either independent variable or a dependent variable, but one variable is studied at a time. The second is bivariate, where we study two variables at a time, and these variables are generally being referred as x and y. You can define them as an input variable and output variable. You can define them as an explanatory variable or a target variable. But the overall objective of bivariate analysis is to understand any kind of associations if exist between those variables. And then we say the multivariate analysis. So univariate is actually used to understand the distribution. Bivariate is used to understand the associations. And then you can say multivariate analysis, where we can study more than two variables at a time. And the overall objective is to know any kind of pattern or trend exists in data or not. So this is how we basically carried out exploratory analysis. And there are two ways of performing them. One, we can go with a simple statistical approach where we compute certain statistics like mean, median, mode, the central tendency, then variance, then standard deviation, then range, then IQR. We compute certain statistics of the data and try to get the insights from it. And the second way of performing EDA is visualization. And that's the most common way for human being, because we human understand pictures better than numbers, because numbers are not good to us. We get confused by numbers, but when we see images, when we see pictures, they're always, appealing to us, and we can easily get identifications from them. Yeah, Ashika, inferential is again like the statistical inferential. Statistical is again the EDA part. So there are two major way of performing expert data analysis. As I said, like either you compute certain statistics like a mean, median, mode, and all this, and tell the story of a data, or you generate certain graphs, the visual graphs for the data and tell the story about the data. So when we talk about visualization way, this is the most common way among a human being. Okay, because we human are more experienced with visual images and all this, so we go with that way more. And here, as you go with bivariate analysis or univariate analysis, we use different kind of charts and graphs to depict the distribution and association shape of a data. So when we go with the univariate, and like data can be of two types, like data can be a numerical data or data can be a categorical data. Okay, numerical data like age. So when you say age is a number like 32, 43, 55. These are numbers. So this is what we call a numerical data. And another variable, let's say gender. So gender is like a male or a female. So this has become a categorical data. So based on the type of data, we use a different kind of charts, different kind of graphs to tell the story or tell the distribution of the data. For example, numerical data is mostly preferred with histogram or box plot or Bayesian plot kind of graphs. Categorical data is mostly used with bar plot, count plot, or pie chart kind of charts we generally use to tell the story of a distribution. Now, when we say bivariate analysis, so again, the type of variables that we use different. Like the most common one is a scatter plot. Okay, then we can use side by side box plot. We can think side by side bar plot. So these kind of charts we generally use. When we talk about multivariate, then you must have heard about pair plot. Okay, or maybe like a three-dimensional plot can be used, and other types of plots can be used to do that. But again, the type of variables that are present, we use different kind of visualization patterns to do that. And again, like again, what is your objective? Whether you are doing comparative analysis or you are doing exploratory data analysis, that is completely depends on the objectives of the problem, and accordingly we will deal with them, guys. So going forward, we talk about EDA and EDA with GenAI. So do we have any readily available GenAI tool that can help us to generate these graphs, these dashboards, and then can tell the story of a data? So yeah, we have, because we have seen, like, talking about the overall process of data analysis. We have seen like we can use GenAI tools for ETL. We can use GenAI tool for data augmentation or synthetic data generation. We can use GenAI tool for uh, data cleaning and all these purposes. So similarly, we can think of having a GenAI tool for performing EDA, guys. Going forward, let's uh, let's talk about some of the concept related to that. So what is EDA? As you already know now, it's an iterative process of questioning, gathering, and analyzing data to identify unseen pattern. So the ultimate objective of EDA is to identify patterns, trend, association shape exist within a data. And once you have this, association shape, it can help you to make better decisions. So it is basically the ultimate objective is to, make informed decision making in the field of business, in the field of science, in the field of healthcare kind of thing. Okay, so that's something what we always talk to about EDA. What are the major challenges of traditional EDA? Means if you go with again the manual way, like when you collect the data, then you clean the data, so it become a very time-consuming process because you have to study each and every parameters individually. You have to look the type of values in it. You have to see the missing values, outliers, curate them, and it is that's something. And when we talk about the human perspective, it is somewhat limited to its own knowledge, like how to interpret, how to see that, and this is where. And another challenge is the scalability, and scalability is a very common issues with the data, and it was limitation on human exercises over the data also, guys. So that's very common. So these are some common challenges or hurdles when we see to perform EDA using manual or a traditional way. So you need to shift on GenAI, and GenAI where you can again expect any LLM kind of tool, and you can simply, prompt it to get your work done. And then if you get the results, it can help you to, you know, um, address different challenges. Like it give you a better interpretations of the data, it give you better insights of the data, so it help you to improve decision making. It required less time, so it accelerate your discovery and innovation process. Democratizing data analysis, that means you can cover every aspect of the data. It is not limited to the human understanding and human knowledge. You can do automatic feature engineering that can tell you about which feature is important, which feature is not important going forward. Then facilitating data augmentation and synthetic. This is already we have already seen that, and we will focus on providing interactive data visualization. That means we will be using some GenAI based tool to do data dashboard creation or visualization dashboard creation kind of thing. Uh, Talking about data cleaning and pre-processing with GenAI, I think we have already seen this, and these tools are really good at that. You know, so whenever you upload any data, you can simply prompt them. They can help you to identify missing values, and later on, you can impute those missing values based on the distribution of the column, distribution of the data. At the same time, these tools are good at classifying the outlier points. And like outlier is any points which is not falling into the actual distribution of the data. We call it as an outlier point. And it can also help you to detect any kind of anomalies or inconsistencies exist in the data. So basically an error detection and all. So data cleaning and pre-processing with GenAI is very easy, and it saves you a lot of time. And this is where we see the major applications of that. Um, then once you have done your data pre-processing, the next thing is that your objective is to perform EDA. And once you perform EDA, the next thing is that you want to do the interpretation of that also. So this process can also be automated. That means generating insights and creating the summaries. So insights can be generated while plotting the graphs, plotting the charts, plotting the different kind of diagrams, and then exploring the hidden patterns within a data. And by using the right interpretation of these graphs and charts, we can actually generate some natural language-based summaries of that. The very similar to the one which we discussed, like if we have two mutual funds having this kind of, this kind of distribution, okay, the mutual fund A or mutual fund B. Now, let me change my story. Instead of, let's suppose, a mutual fund, let's suppose these are the two companies' salary distribution. So this is the distribution of the company A employees, and this is the distribution of company B employee. Now, both the companies have the same average salary for their employees, but the very first company A has a less distribution, and the B has a more distribution variance distribution available here. Now, let's suppose if you are getting offer from both the companies, which company will you join, guys? Company A or company B? You are going to join company B. What is the reason that why you want to join company B? Because in the company B, you see there is a large variance, Vetki says. So you have more chance to get more increment or a larger increment over there. So you have better chances to grow over there in terms of your salary. That's why you should prepare company B. And that is what we basically try to tell in natural language. So when we generate the summary, we try to tell these kind of the points, and this is what we call storytelling, especially for the non-technical stakeholders. So if you simply tell the story of the data that, hey, the company way has a mean value of mu a and the standard deviation of sigma a, it will not be understood by the non-technical person or non-technical stakeholder. So what you have to do, you have to tell the story of data in a very native common language with some examples, like what happens when you have a less variance, what happens when you have a more variance, the risk will be more, the risk will be less, opportunity will be more, opportunity will be less, kind of thing. So that is how we basically tell the story, or that is how we basically interpret the data, guys. So so this is all about understanding the patterns. So pattern recognition and its importance. I think we have already covered this, and I have repeated it many times. Uh, These uncover insights, support strategic decisions like identifying customer segment and prediction trends and all. So I think we are all good. Anomaly detection and its challenges. So anomaly detection is again a kind of pattern detection. The anomaly is anything which is not within the overall distribution of the data. So anything which is deviating to the overall distribution of the data, we call it as an outlier. An outlier is an anomaly. And sometimes this anomaly detection help you to solve many, you know, many industry problems like credit card fraud detection, the cyber attack detection, these kind of things. Because whenever we see these kind of data points, they must be different from a normal data point. So whenever the data behaves abnormally or the distribution is outside the overall distribution of the data, that kind of behavior is basically known as a anomaly behavior, and that can easily be predicted correctly. So some of the challenges what we do in anomaly detection is that when your data is become a high data and that become a very complex, so it will become very tough to find out the anomaly from there, and especially when we are doing manual exploratory data analysis. If you are working in a domain where the patterns are very dynamic, especially the social networking kind of domain, especially the customer segment kind of domain, where the patterns are very dynamic, the customer switches from one segment to another segment, like that. And when there is a lot of risk involved for the false positive, which means that if the particular the classification is not correct, but you make it positive, then there is a lot of risk involved into that. So while doing this, there are a lot of risk involved that, and so you always try to get better and more efficient techniques to do that, and you want to move from traditional EDA to more GenAI based EDA, where the possibility of error is less. So when you go with GenAI, obviously you increase with an accuracy and precision in detection. You can handle more larger volume of data. That means the scalability for big data is available, and early detection and risk mitigation is also being there. So that's where we see the advantages of GenAI in anomaly detection lies. So we are talking about different domains and different areas and their challenges and how we can cater these challenges with GenAI. Even in that sense, like if we are doing some real time data monitoring, and this is something we do a lot in industry when we monitor any machine learning or deep learning model, and we want to have a continuous monitoring system running at the back end. And if your model is deviating from its normal behavior, we try to kind of put an alarm for that. So that is also one of the domain where we come up with certain standard metrics. And if your observation falling beyond the metrics, then you alarm. If it is going with the metrics, then you keep it continue monitoring. So can we replace these systems with the Gen AI systems? Yeah, the answer is yes, because they have better data analytics domain and data analytics power, guys. So GenAI can identify deviation from normal patterns, notifying relevant teams for potential issues. So this second thing can be done very easily. Instead of simply putting an alarm, we can write a well-drafted email, because these models are very good at articulating languages, articulating text, and all these things. So we can draft a proper email and we can send it. This can be automated. Gen AI allow teams to set threshold and receive alerts when these are breached. So this is again like kind of a system which trigger the alarm. And more example of use case include monitoring network security, identifying sales. That is something I've been said, like we are monitor a machine learning model. Similarly, we can monitor other behaviors of the systems. Like we are monitoring network security, we are monitoring some sales product kind of thing. And if we see any kind of fluctuation in there, any kind of deviation is there, that is something we should alarm. So that's what we call a real time data monitoring, guys. Let's talk about one of the Gen AI based use case in business. Just for a dummy, the Lenovo Brazil adopted a data robot automated machine learning platform to predict product sale out volume for their retail partners. So if you remember that, we talked about data robot. Data robot is a kind of platform that basically help you to create a complete end-to-end automatic pipeline to perform EDA, model building, and even predictions. So we can think of a GenAI based solution to implement a complete end-to-end system that can automate your overall process of analyzing a data, understanding the pattern of the data, forecasting based on the pattern of the data, and then taking the right set of decision. And when you use such kind of Gen AI based model, like a data robots kind of model, it will reduce around, you know, 70 to 80% of your overall time, and you can achieve better prediction accuracies because you are actually following all the steps accurately and try to minimize the errors by maintaining the data integrity in the process. So yeah, these models are always good to have. And with this, let's jump on to another case study on performing EDA on large data set using Julius AI. So it is again, we will be going back to our Julius. We will be using a bit, the larger data set in terms of uh, data size and all, and then we'll talk about how we can perform it, guys. So let me take you back to our Julius background. So I think this is where we have Julius. And what we're gonna do is we're gonna first upload our data. Okay, so let me first show you the data, and please download this data from the LMS. I've already downloaded it on my machine. So this is the data set that is given to us. Ideally, it is a very large data. You see there are a lot of number of rows and number of columns are given in this data, with some large number of values are also being populated here. And if you see, this data has, the column like country. And then I think the population of the country is in different years, like 1960, 61, 62 kind of thing. So this is the kind of data that is given to us. What we have to do is we have to perform a detailed EDA using Julius. So again, you need to log into a Julius platform. And what you have to do is you can go to your Google first and then simply type Julius AI over there. You can click on it. That will take you to the homepage of Julius. Again, by using a Gmail ID, you can log in into the page and you will be seeing such types of pages over here, guys. So the next thing is what you have to do is you have to download your data. So I believe you have already downloaded this data. This is a data.csv file that, that's supposed to be available on your LMS. And what you can do is you can simply upload that file onto your Julius platform. So again, you should click on this plus button and you get different options like upload from Google Drive, personal drive, SharePoints, My Files, like that. Or you can, connect this to a different sources as well. But we have this file available on our local machine. So I'm actually taking it from there and uploading this file. Uh, so once you are ready with that files, what we're gonna do is we're gonna start performing different uh, operations that we generally do manually, guys. Now you see this is the kind of file that we have here. So the very first thing is what we want to do is we want to understand whether there are any missing values, any null values present into this data. Or if there are any missing values, what we want to get the summary of these values. And once we get the missing values, like here you see that there are certain values which are missing. This null value is here missing, this null value is missing here. So depending on the nature of variables, we want to, handle them appropriately. So when I say handle them appropriately, which means that we want to impute them. We want to replace this null value with an appropriate number. So what you can do that, the one of the best way of dealing with these GenAI tool is prompting them. So you can write a very simple prompt that identify the null values in the data set across all the columns. Okay. Then we say that provide a, a brief summary of the count of null values per column. Let's suppose that is also we are interested to know. And finally, we want to handle them. So depending on the nature, or you can write depending on the distribution of the columns. You can write it like that. Nature and volume of the missing values, implement the appropriate strategy to handle them. That's it. So we have written a very simple prompt to deal with the missing values like that. So first is we want to identify that how many missing values are present in this data. Second, we want to get the brief summary of those missing values. And finally, based on the nature of the values and the number of missing values are there, we want to apply some strategy to handle them. If I hit enter, it try to analyze your data, it try to get some summaries kind of things. So, it is again writing a Python code for doing this that help you to read the data and it kind of giving the missing value summaries. So you see that we have different columns, the columns like 1960, 61, like that. With respect to each of these columns, we are getting like how many missing values are there. Guys, are you following? So like in 1963, there are two missing values. In 1964, there is one missing value. 1965, there is one missing value. So like that, we are getting missing values. Now this is showing the count of null per column across the entire data. The next thing is that we want to, get the appropriate replacement for these missing values. And this is where like we first are getting what are the number of missing values across each of the values. And then it is a proposed missing imputations that we are getting. So this is a sorted summary of null counts and proportion of the missing value. That means out of in the column of 1968, um, you know, uh, almost 0.01% values are missing. In 1969, also almost 0.01% values are missing. And for the other columns like 2019, 2007, 0% values are missing. Now talking about how you can handle. Okay, so the most common way of handling the missing value is what you can think of. You can think of imputing those values. And this is something you can do by either using a mean value or a median value based on the type of column and strategy for that. So again, because you have prompted it like that, based on the nature and the volume of missing values, implement an appropriate strategy. So this data is a time series data. It's like it is giving a timeline 1960, 1968 kind of thing. So going with an appropriate mean or appropriate median is not the right strategy, because that can send you back into the task. So here what we saying, for numerical year columns, we will use linear interpolation. That means it is going in a linear way. And if the leading trailing gaps exist in country, that interpolate can be filled. So for example, let's suppose if I'm talking about 1968, which is having almost three missing values. So what can I see is I can look the values from 1967 and then 1969 and try to interpolate the missing values, because that is the kind of series data what I am having here, guys. I hope you are understanding what I'm trying to say. Are we good here? Yeah. So, based on the type of column, the nature of data, you have to come up with a different kind of strategies to handle the missing values. So that is what, we can think of that. So, Yeah, that's one thing. Okay. Uh, let's say you are going to perform EDA on it. So when you perform EDA on it, as I said, like you can go with two ways. Either you can try to generate a statistical summary of a data, or you can look for some visualization charts or visual graphs for that. Let's first go with some, computing some statistical summaries of your data. So let me prompt it again. Calculate and interpret the summary statistics for each year in the data set. And you can also provide the insights of the central tendency and variability. These are the two parameters we generally variability. We generally study to get the distribution of data, guys, across data set. So if you prompt it again with a different instruction, it will simply load the data and it will try to, generate the statistical summary. And when we say statistical summary, we talk about mean, median, mode, standard deviation kind of thing. So you see that this is like we are getting mean, median, standard deviation, minimum or maximum type of values can be seen here, guys. So median is generally being considered as a Q2, okay, 50 percentile value. So here you see that in the year of 1960, okay, we have like 266 total values with an average of this much, with a median of this much, with an standard deviation of very high variance that can be seen here, guys. With a minimum value of 2646 and the maximum value is almost like 1,000 lakhs, more than 303 crores, like that. Now, so this is like you are getting a statistical summary of your data. And this is actually giving for some of the columns like the summary, but you can expect this to, when you download, you'll get the summary across all the years. You are only getting the display for the top 5 years. But here you see like, the interpretation in terms of central tendency and variability. So what it is saying for the central tendency, the yearly mean and median both increases over time, indicating overall growth across countries. The median is far lower than the mean, which suggests a highly right skewed distribution. So that is always remember, guys, what do we call a skewed distribution or what do we call a right skewed distribution? So whenever we see any kind of data with some values, we expect the data should be normally distributed, where you see the equal tail on both the side. That is what we call a normal distribution, but it is very rare to form. Normally, what we see, a tail on one side, maybe kind of this. And these kind of distributions are known as skewed distribution or asymmetric distribution. Now, when your mean is greater than median, so if let's suppose if this is median and this is your mean, so when your mean is greater than median, your distribution is a right skewed. That means you have a lot of high outliers into that. Guys, are we familiar with these terms like mean, median, and all? And when your mean is smaller than, smaller than median, then it makes the distribution left skewed, or there are a lot of low outliers present in your data. So while looking the statistical summary, we can clearly see that your mean is pretty much higher than your median. So the median is, it's sum of 38 lakhs something, but it is like 170 crores or something like that, or 11 crore. So mean is very much higher than your median. That shows that it is a right skewed distribution. Whereas if you talk about the variability, so that is also showing a very high variability. This is a standard deviation which denotes your variability, guys. So every year we are seeing a very high variability across different countries options that is given to us. So that's how we can tell or we can interpret that. So the standard deviation is very large relative to the mean and remains high over time. This reflects substantial dispersion driven by the large population difference between small and very large countries. The gap between minimum and max is massive and grow over the time, further underscoring issues and inequality size of all the countries. So this shows that this data is highly right skewed, and there is a big gap between smaller size countries and a big size countries population. So there are countries where the overall population in the year of 1960 is one country, 46, that means only 2,646 individuals are there. But at the same time, there is another country where we have a population, or continent we have a population around like 30 crores or more, like that. So you see this shows the very big gap between a smaller size country population and a big size country population. Now, what we can think of, so this is known as a univariate analysis, where we are considering one column at a time. But we can think of conducting a bivariate analysis also. We can conduct of thinking correlation analysis. So let's suppose we want to understand the relationship between uh, in some patches, some that. So we can write another prompts to perform correlation analysis. What I'm writing, calculate the correlation metrics for the data from 1960 to 2022. And once you found the correlation, we also wants to understand the insight. So we can write like discuss the implications of high and low correlation between different years, and what might suggest about the data consistency and reliability for model building. So, this is where you can even ask that how good is this data for model building? So it is again going through your Python script, which will be executed over your data set. This will generate correlation matrix. Correlation matrix basically help you to understand the relation between two numerical variables. It's like a pair plot, and then we can get the value. This is a big matrix, so you know uh, a very high correlation where we can see that all these values are filled with +1. So they are highly positively correlated. As you are increasing, like it is keep on increasing. So we can say there is a positive relationship. As you are increasing with the years, the population is also increasing. So when you see such kind of heat map, the basic interpretations what we get that the correlation values lies within -1 to 1. So when you see the heat map, the values will always within this range. Uh, if the value is negative, the correlation value is negative, this shows a negative relationship. If the value is positive, that shows a positive relationship. Okay, so negative relationship means that increase in X result decrease in Y. And positive relationship means increase in X results increase in Y. Both will go on to the positive direction. So that is how we interpret negative and positive relationship. In terms of the value, if the value is somewhat between 0.7 to 1 or between -0.7 to -1, this type of relationship we call it as a strong relationship. That means change in X definitely reflects change in Y. If you find a value within, let's say, -0.3 to -0.7 and 0.3 to zero point 0.7, you can think of a mediocre relationship. Okay, so that means if X is increasing uh, approximately, Y will also be increased, but not very significantly. And when the value lies within this range, we call it as a low correlationship or low associationship kind of thing. So we generally look for the values. As you see, like this particular graph is completely filled by yellow. That indicates that all these values are very close to 1. All these values are very close to 1. That means these values are positively correlated. These values are highly positively correlated. And by increasing the years, the population is also increasing across the countries. So this is how we can perform exploratory data analysis, and we can actually get the insights from it using GenAI based tool. Now we are on the time, so let me quickly talk about the remaining part, and then we can conclude this session, and I'll take your questions as well. So this is another questions based on Julius AI, guys. How does GenAI address the challenge of traditional data exploration by automating data preparation and highlighting complex pattern, by eliminating the need of data analysis, by limiting the analysis of a small data set, by providing fixed non-iterative insights? What do you think? What is the right option? Okay, so next is visualization of data. So as I said, like we can do this EDA in two ways. Either we generate a statistical summaries, or we can generate some graphs and patterns. Um, so again, like the traditional way and GenAI way. So we are all advocating GenAI for better efficiency, better adaptability, and better data handling process and all this. So these are some of the uh, points over which you can compare your traditional approaches with GenAI enhanced data visuals approaches. And once you introduce GenAI in data visualizations, you may expect predicting trend and outlier detections, automating data cleaning, and these all things we have been talking since the beginning, guys. So this has all remained the same. Some of the key use cases that we can think of, especially for data visualization in different fields, is like a retail company where we want to understand the sales data. We want to make predictions about the different trends, and visualize some potential sales spike to improve inventory management or something like that. So that's very much correlated with the very first example which I gave. Like when you see the increase in temperature, you observe increase in ice cream sales. So if you see like going forward, the temperature is increasing in your territory or in your neighborhood, you want to keep your inventory ready for that. So you want to store more ice creams for the sale. In the finance side also, GenAI highlights unusual transaction patterns that help you to, do some fraud transaction detection kind of things that can also help you to minimize some risk and all that. In e-commerce, these tools can help you to analyze or understand customer reviews, customer ratings, and then help you to make better predictions, better recommendations, more personalized recommendations, and all these things. Uh, these are some popular GenAI data visualization tool, and I would request you to try them. Like Data Squirrel is one, Google Charts that you can try. At least you can try Google Chart Assistant. You can simply load your data and try to generate some interactive charts, guys. And once you generate these charts, it will look like to be this one. And you see like the basic charts, what we plot are either line plot or a bar plot or a stacked bar plot or a pie chart kind of a plot. We call it as a donut plot. And these plots help us to see the pattern association shape or any kind of train exist between them, guys. Um, yeah. So when you have the interactive dashboards, and especially when you prepare them to a GenAI, the basic advantage that you get, like, you can explore data to gain more deeper insights. You can write stories using them. Uh, Having an interactive dashboards, you can customize dashboard to improve your relevancy and usability. As your data is changing, automatically the chart is changing, and you can get instance pattern identification over there. So you receive immediate updates to respond trend promptly. And that can actually enhance your team communication and collaboration. So you get instant alarm and all these things on that. Examples like data-driven infographics, interactive dashboard, and personalized marketing. Again, like, very same thing. Uh, that is something, I would request you to cover, and I can explain you. So this data set is also available, and you must have a walkthrough Word file as well. So I request you to please go through with it and make it complete. Data storytelling with Julius AI. So we have already seen the Julius AI platform. All you need to upload the data and prompt it differently to get the storytelling for that. Uh, yeah. So lastly, I will talk about some of the questions. And if you have any questions, guys, please let me know. So I'm quickly take you to where uh, you know um, there are some questions like which of the following is a key application of generative AI in clinical data analysis? Okay, this is related to the use case study, guys. I'm sorry. So let me summarize the key takeaways and please let me know if any one of the point is not clear to you. So the very first is GenAI allow for real-time customized experience, making data visual, interactive, and insightful. Are we all agree that now we have a very clear understanding that how we can use GenAI for real-time customized experience, making data visual, interactive, and insightful? Can I say that, guys? Are we at a state where we have understood this process end to end? Can I get your thumbs up or thumbs down? Thank you. Uh, can I say now we have understood that GenAI can streamline processes, enhancing accuracy, and reducing manual efforts? This is something we have understood. Can I say now that GenAI allows team to set threshold and receive alerts when these are breached, making it ideal for fraud detection? Or can I say that GenAI combines data, visuals, and narrative? Narrative means the interpretations what we write for actionable executive insights. Can we say that? The great. So these should be the takeaway from our discussion, and I hope we have a very clear-cut idea about them. So let's have a quick knowledge check with some of the questions. What is the first step in the data analytics process? Data visualization, data ingestion, model training, or report distribution, guys? What do you think? What is the right option? Data injection. That's very right. We first need to collect the data. Which of the following GenAI tool is known for automating EDA tasks? Microsoft Excel, Julius AI, Figma, or Visual Studio? Julius AI. We have seen that. That's very good. How does GenAI help with real-time data interpretation in integration in pipeline? Causes delays in data processing, introduce unexpected lags, enables automated real-time data flow and transformation, expand the amount of data stored. What do you think? How does GenAI help the real-time data integration in pipeline? Anish, right. Option is C. And what is the one major difference between synthetic and augmented data? So synthetic data is generated from scratch, while augmented data is modified real data. Synthetic data is generated from scratch, while augmented data is modified real data. Synthetic data is fully artificial, while augmented data builds upon actual data with added variations. Uh, synthetic data simulate. So synthetic data is generated from scratch, while augmented data is modified real data. Uh, I think the option is C. There is some a mistake in that. I completely agree with you guys that. Which GenAI tool specializes in privacy preserving synthetic data generation? JPR, Power BI, mostly AI or Snowflake. So we'll continue our discussion, and today we'll focus on uh, the concept like data modeling, like how you can use Gen AI for data modeling, forecasting, and we will also touch some of the practical challenges like when we go with Gen AI. So very first, we will first try to understand that how Gen AI help us to work with data modeling. Okay, so when we talk about data modeling, like how you should organize your data for better study, for better accessibility, and when we talk about the overall organization of our data, we talk about database schemas and all these things. So can Gen AI help us on that as compared to your traditional way, like where you need a data experts which can help you to data generate data models and data schemas to store different types of data. So we will talk about like how GenAI can help us on doing that. Let me quickly see it. Okay. The second is we will also talk about to identify the key applications and benefit of generative AI in data modeling to enhance decision making. So obviously, like if you have a better data models, you can retrieve data in fast manner. You can get better insights, better informations can be drawn from the data. So that help us to enhance your decision making process. So we will talk about some of the use cases where we will play some data sets, and we try to get the insights that help us to make some better decision making in the process. Then we will talk about that how GenAI can help you to make forecasting. So this is something which come a very next step of data analysis. So when you see any kind of associations if exist between variable, or when you see any kind of trend exist in the data, can we utilize that association shape? Can we utilize that trend to make future predictions or future forecasting? So this is also where we look the application of GenAI, that can we use GenAI tools to make forecasting and how it supports more accurate prediction. So considering the traditional approaches where we use some statistical model or some conventional machine learning models to make predictions, but if we go with the generative AI models, can we enhance the state, or can we make better predictions or more accurate predictions while using these models? And finally, we will also talk about, as I said, like we will touch upon some of the challenges related to when you try to integrate GenAI in overall data analytics process. So what challenges you will see, the challenges related to data quality, the challenges related to the model complexity. So we'll talk about these challenges, and hopefully we will also understand how you can overcome these challenges and where are the major gaps between integration of GenAI in an overall data analytics process and all this. So these will be our learning objectives for today's discussion, guys, and we will uncover them one by one. So the very first thing that we will look upon the application of GenAI in enhancing data modeling. That means, when you prepare a data, how you can use GenAI to enhance that. So first of all, let us first try to understand like what is the data modeling. So when it comes to any kind of use case, you think of creating a data, you think of collecting a data, and then you want to organize that data into a proper way through which you can analyze that. So when you start collecting a data, you basically try to define some concepts. The concept that talks about the key entities that you want to collect, the different kind of attributes you want to collect across these key entities. For example, if you go for the shopping mall, and let's suppose you want to create a data model for shopping mall, so you definitely talk about the product, you talk about the customer, you definitely talk about the season or the demography of that particular product, something like that. So you talk about certain key entities that you want to study, that you want to collect the information, and across each entities you actually collect data for over certain attributes. Like if you talk about product, so you may interested to know about what is a product ID, what is the sales in particular season on a month basis, what is the total inventory that you have, do you see any peak in sales. So these kind of informations you want to collect over the product entity. Similarly, on the customer side, you would like to know what is the name of customer, but sometimes it doesn't matter, so you can look for the age of a customer, the gender of a customer, okay, the demography of a customer. So these are the different attributes that you would like to, collect with respect to the customer. And similarly, other factors can be collected. And then you look like how these units are interrelated to each other. Do we have any kind of relationship? So we try to create a conceptual understanding about data set, and then we try to conceptualize our data. The very next step that we do is we try to incorporate some technical requirements. So when we say the technical requirements, obviously the details that we are collecting, the data will have standard data types. So we want to capture that particular data in that format. And we want to, maintain the logical relationship between them as well. So it should not be that we are collecting categorical variables for numerical entities, or numerical data for a categorical entities. In this way, you overall introduce inconsistency in your data. So we basically try to be a logical while developing these data model. And finally, like you try to convert the logical model into a physical explainable environment where you get the complete schema of your database. or you can say the complete data set schema should be generated over there. So that is where we generally talk about developing and creating data models for any kind of domain or any kind of study. And after that, like you start making the study over this data. So with this, we can think of, like these kind of stages while understanding the data model. So we mostly talk about the relationship in terms of a structured format, enabling the analysis of the complex data. So that's your final goal, and that's your final objectives is going to be. Now, can you think of any other domain, and can you tell me, like, if you have to design any data models, how you define the key entities and the attributes of that? So HR is one of the domains. So if let's suppose you're working in HR domain, how you identify the key entities and the attributes of these entities? So there can be, different domains, and then accordingly, you can identify the data points and all this, guys. Okay, so this is like where we talk about data modeling. You first understand the domain, and then you create your logical understanding about that domain in terms of the entities and the attributes of these entities to be played. Now, talking about what are the essential role of data modeling in data analytics, like if you create a proper data model, that will really help you to get the right data analysis process. Because if your collected data is inconsistent and it is badly designed, you may end up of getting wrong information or wrong insights at that. So it's very important when we talk about the role of data modeling in data analytics, and it can be understood by some of these important points. Like the first is data structuring and for accessibility. So that is very important, because when you analyze the data, you have to access data in efficient manner. If you organize data in a very bad format, it will always create problem to access the right piece of information. So structuring of data is very important. What we generally do, we generally organize our data in a relational database manner, and that is nothing but a tabular representation of our data. So when you talk about a tabular representation of data, we say that each entity is being recorded on some attributes, and the instances of the entities are being recorded on the row wise. So for example, if I say customer is one of my entities, so I can record the different attributes of the customers in terms of customer ID, the age of the customer, the gender of the customer, the total spend of the customer, or any other attributes that you can record. So this is the most common way that we generally use to, structure our data, and that's what we call data structuring and, accessibility. Now, why we want to have this kind of structure? Because it is easy to access, it is easy to understand, it is easy to query and all these things. So that's organization of data is very much important for easy access and easy query and interpretations for that. So when you have a proper formatting of the data, it supports you to the better accessibility. Then next thing is what we look is what is the quality of data and what is the consistency against the data. So, this is something we discussed yesterday also, that while doing the data analytics process, we always want to, maintain the data integrity. So the every stage that you follow in the data analytics, it should not disturb the values of the data, and it should preserve the integrity of the data. So when you talk about the overall data models, we want that data quality and the consistency should be maintained across the different stages of the process. And finally, in that process of data analytics, we talk about feature extraction, where we talk about the important variables which are more significant for the study, that have more strong correlation with the target variable kind of things. This is what we call feature extraction. For example, let's suppose if you have an unstructured data, like a text of an email, and from that you want to extract the right set of words which help you to categorize whether a particular email is a spam email or not a spam email. Similarly, let's suppose you have another unstructured data in case of images. So you want to, extract the features from that image, and you want to represent that features in some kind of numbers that can help you to do better image classifications, like whether a particular image is a cat image or a dog image. So that is where we talk about feature extraction, and this is also one of the very important stage of data analytics in the data modeling, guys. So when we talk about the key roles of data modeling and data analytics, they can be, first organizing your data into a structured manner, and most probably it is always a tabular representation. Then check for the data quality and the consistency of the data. So there should not be any inconsistency exist in the data. We try to have a better quality data for making a more reliable and consistent models, and extracting the more robust insights from it. And then we talk about, while performing the data analytics, we talk about feature extractions, where we talk about important features to be extracted in the process to make the target variable more predictable or better predictables kind of thing, right? So these are the basic roles, and with that, like you can simply address why it is important. So you can say the importance of data modeling is it help you to strengthen the data management and the organization of the data. The second, it improve the data quality and integrity. So if you have a right data modeling schema, it definitely improve your data quality and the integrity of the data. When you have a better quality data, when you maintain the consistency of the data, you maintain the integrity of the data, you can say it enables the better decision making, because at the end of the day, you are using the insights to uh, get the data driven decision making, guys. uh, the better data model enhance communication among team, so everyone can easily understood like what are the key entities, what are the attributes about that, they know the meaning, so it helps to have a better communication among the team members. If you organize the data in a proper way that supports scalability also, that means you can keep on adding new rows or new entities or new example sets into the data, so that's good for the future growth, and that also ensures the compliances and data governance. So these are some of the some of the key benefits, or you can say the importance points that are related to having a better data modeling in the process of data analytics, guys. Are we good here? Do we have any question, or you want me to explain it to it from different perception? Okay, so let's list out some of the benefits of data model, as we have already discussed this, and this is keep on coming repetitively, that it enhances the data understanding. So when you organize your data in a structured way, you have a better way of analyzing, you can maintain the data quality. So it help you to understand the data better. It optimizes the data storage and retrieval. So now you have a better way of organize the data, as well as you can do better retrievals. You can reduce the data redundancies. So, whenever you organize the data, either in the form of a data frame or a tabular approach, it is far easy to know whether there is any redundancy or duplicacy exist in the data or not. And finally, like, the sentiment analysis, this is like, talking about the reviews. It's not related to the general use case, but like, you can easily get like what are the sentiments toward the data, positive, negative, or neutral kind of thing. So that can help you to achieve this. When you compare the GenAI methods of data modeling versus the traditional data modeling techniques, you get certain advantage over them. And the key parameters that we can use to compare the traditional approaches versus the GenAI approaches is that, first of all, like the methodology, like how you are going to, perform the data modeling using two different techniques. The very first is these are relies on a predefined rules or human expertise of structured data. So, the common techniques that we generally use to assess the quality of data is you doing some exploratory data analysis, univariate data analysis, where we talk about some statistical methods, study about mean, median, mode, standard deviation, ranges, and on the basis of that, you decide whether a particular variable is a qualitative data or it's not a qualitative data. So these techniques are mostly rely on human expertise and some statistical techniques that you run over a structured data. When you talk about GenAI techniques, like these are more advanced techniques. They come up with some machine learning, sophisticated techniques that help you to understand more deeper pattern of the data, and then you can give the better relationship within the data also. So as compared to the traditional techniques, you can say like these are more advanced machine learning based sophisticated techniques that can be used. Um, Talking about the scalability, as you know, like if you have any human expertise involved or if you work with statistical models, they are always limited by the size of data. So you can't, run a statistical analysis on a very huge amount of data. So managing of a large and complex data set, making scalability challenging, and it's very time consuming also. But when you come up with a Gen AI based approach where you are using some deep learning and machine learning models, so there you can literally process a large volume of data and you can get real time insights out of that. Adaptability is the next thing. So, like when the data changes, you have to change your techniques. The techniques with what you use to analyze the numerical data will be completely different what you use to analyze categorical data. So, the adaptability is what one another challenge. When you change your domain, when you change your data set, you have to change your techniques for validating your data and uh, creating a data models out of it. But with the Gen AI, as you know, like this is surpassing the current human expertise level. So this is very quick in adapting the new data and it improved the accuracy by over the time. Data dependency is like it operate effectively only on a well-structured or a smaller data set. So when we talk about the study techniques that you use to, model data, they are mostly be derived through a structured data where you have, either a tabular representation or a series representation, and then you can apply these techniques. But Gen AI techniques, you can run it over a high quality, even on unstructured data also, because these models are trained to work with both type of data, structured as well as unstructured data. And talking about time, so obviously, like this is something we are discussing since last day. While using a Gen AI, you can literally improve your working efficiency. The task what you usually complete in 100 hours, you can save like 80 to 90% time when you go with Gen AI models or Gen AI techniques. So this is like, you can think of enable faster implementation once the data is prepared, and you can automate the whole pipelines. So these are some of the benefits you get when you compare the Gen AI enhanced data modeling versus traditional data modeling technique, guys. So now let's talk about more about Gen AI enhanced data modeling, like what benefits you get and where you can see the impact of these benefits over the business. The very first is like now you can prepare an automated data preparation. Now, when I say the automated data preparation, that means you get your raw data, and you can feed this raw data into any Gen AI tool. You can think of prompting this Gen AI tool to, pre-process this data. When I say pre-processing this data, that means I can expect that this particular tool can clean the data. That means it can remove any kind of inconsistencies. It can remove any kind of redundancies from the data. Then if it is required, it can also transform your data to a different encoding, formatting, and all these. And finally, you can, save this data to a better format. So this is what you can think. So the overall data pre-processing can be automated by Gen AI tool. And if you do so, the business impact is that it help you to make faster decision making. Okay. So whenever there is any change in the data, you can directly feed into that, get the insights from it, and ultimately you'll get faster insights, and then you can use these insights to make faster decision making. Next, coming to a feature engineering, and like what we call a feature engineering is, let's suppose you have been given with certain n number of attributes in your data with respect to any target variable. Feature engineering talks about selection of important features which are significantly associated with your target variable. So by using Gen AI tools, we can do efficient feature engineering that can help you to extract the important input variables which are highly correlated with your target variable. That can also be done automatically using these Gen AI tools, and that reduce your manual efforts. So when you go with the right set of features in the model building, in that sense, you can expect that your model accuracy will be enhanced, and that model will provide you more reliable um, and best predictions to support your decision making, guys. So this is another advantage that we can think of, like where we talk about efficient engineering. Now, talking about next, when you use GenAI, it is related to the enhanced pattern recognitions. Like as a human being, we have limitations. Like as we talk about visual representation, you can only plot data in 3 dimensions. You can't plot data more than 3 dimensions, and your perception towards look that pattern is also limited. So you can see the very standard kind of patterns, or you can only recognize very standard kind of patterns when you see that, whether it is a positive correlation, negative correlation, or some kind of grouping can be seen into that. But if your data is a multi-dimensional, let's your data comes with 10 number of dimensions, so you can't see this data uh, in one shot in all 10 dimensions. You have to reduce this data up to 3 dimension, and then you can see the visualization of that. But these GenAI models are, it's good enough to identify these complex patterns, and they can actually see these correlations because they come with a lot of computational going behind the model, and then they help you to enhance pattern recognition also. So in that, if you can recognize better, deeper pattern of the data, that can help you to improve risk management, fraud detection kind of things, anomaly detection kind of things also that. Then finally coming to this is predictive modeling and simulations. So when you have a right set of features, you recognize the right set of pattern in the data, you can build more robust model that can forecast future outcomes. And that's something what we want. Like, so the overall data analytics stage ends when you are able to make predictions for the future events based on the historical trends on that. And using that, you can literally impact the different dimensions of domain. For example, let's suppose you can optimize the inventory. You can anticipate the demand of any product. You can enhance the customer satisfaction. So let's suppose you predict that customer is not happy with your services. If you can predict that in advance based on the certain characteristics shown by the customers, you can actually address them. You can address it personalized recommendation kind of way, and you can literally address them. So it help you to sustain your business. It help you to improve your businesses like that. So that's the ultimate goal of data analytics, what we say, guys. Talking about data model optimization, so this process when it become automatic, it automatically fine tunes your models with new data. It understand the data pattern and this, so it increase the model efficiency and it reduces the operational cost as well. And finally, with this Gen AI, you can think of having a continuous learning and adaptation system. So when you see there is any drift in the data, accordingly you adopt it, you monitor that the model is not performing correctly, you make it correction, include new data points to retrain the model. And in that way, you can say that by the time your AI model adopt autonomously, and it enhance its services or its prediction quality by the time or overall period of the time. So the business impact of this is like it maintain competitiveness by adapting the real-time changes and enhancing the resilience in the process. So these are some of the the benefits that you can think of when you include GenAI enhanced data modeling into the process. Uh, Again, to get it done, we are all talking about automating the data analytics process, guys, and the data analytics using GenAI. Like the tools like ChatGPT, the tool like Cloud, the tools like Microsoft Copilot, the tools like Julius, what we have seen yesterday, and the tool like um, ChatGPT or Gemini, like that. Sorry. So now let us see that what are the key techniques that are used in GenAI enhanced data modeling. How we can say that when you introduce GenAI techniques in the process of data modeling and data analytics, what are the key techniques? So, now we are talking about forecasting and data modeling. And forecasting is where we talk about different kind of machine learning algorithms or models to do this forecasting. So we have different machine learning algorithms that basically help us to build some predictive models. Now, what are these predictive models? So the role of these predictive model is that they basically study the historical data pattern. And once they understand the pattern, the understanding can be used to make future predictions. That's what we do. That's the primary role of any machine learning model or any machine learning app. So you try to feed the historical data or the past data. That data has certain pattern into that. These models have ability to understand that pattern and then express that pattern in some kind of mathematical relationship or any kind of relationship. And that relationship can help you to make future predictions over that. So by using these machine learning algorithms, what you can do, you can make predictive models. These predictive models can help you to make predictions by understanding the data patterns. The very similar approach can be done by deep learning also. And we say that deep learning is a subset of machine learning where these models are based on a different philosophy. And that philosophy is purely inherent from our human brain analogy. So these models are known as neural network. Now, because these models are complex by their nature, so they can actually work with a complex data or they can work with more unstructured kind of a data. So these models have ability to understand complex data pattern, such as images or textual or sequences like that. So, now you have a better machine learning model that can deal with the more complex data, can understand the complex pattern of that complex data and can generate predictions out of it. So deep learning is you can say a subset of machine learning. We can say that. And sometimes we go with ensemble learning, where we try to combine multiple types of models, and then try to get better accurate models that help you to do better predictions and all these things. So there are different techniques that we think of, like going with a machine learning side. But when we see our data, like data can be of different type. So data can be a structured, data can be of unstructured. When you talk about the structured data, it is mainly being represented in the form of tables. And when you talk about unstructured data, it can present in a form of image, it can present in the form of audio, it can be present in the form of text, any kind of a speech signal kind of thing. So data can be of any type. You may have a social networking graph is also there. So that is also a type of unstructured data. Now, when we expose this data to any of the model, the role of the model is to understand the pattern of data and then utilize that understanding to make pattern. That's what we see the ultimate objective of machine learning models and models. So when your data has changes, these models have a characteristics that these models expect a feature vector of any data. And this model only deals with this feature vector. And this feature is, you can think of having a real valued vector. So whatever the data it is given to you, whether it is a text or it is an image or it is an audio signal, you need a way through which you can convert this type of data into a real value vector. And so that input data can be represented by a real value vector. So this model can understand the pattern of that real value vector and generate the predictions out of it. So that's it. So you need a way through which you can actually map it. So going with the techniques, what we do in the forecasting is we required some kind of natural language processing techniques that help you to convert a textual data into a vectorized representation. Then we talk about computer vision. It is a separate domain where we talk about the techniques that deal with how you convert an image into a real value feature vectors kind of thing. And so we have a different domains, and according to that, we have a different techniques. So one of the natural language processing, it is a domain which basically deal with a textual data, or you can say a language data. Okay, and we talk about different kind of techniques under this, like tokenization, vectorization, and transformers for applications such as sentiment analysis. So this is a separate domain under deep learning, which deals with a specific type of data, which is a textual data, basically. And in the year of 2017, that transformer model was introduced, which laid the foundation of GenAI, guys. And that was again a language model at that time. It was designed to do the language translation task. So when you give one language sentence, it's supposed to translate that sentence into another language. And the very first model that was designed by Google was to, I guess, English to Spanish translation, language translation model to that. So that particular model was known as a transformer. And since then, we have seen a complete revolution in the field of artificial intelligence. And this model laid the foundation of the current GenAI models, this LLM space, what we are saying, these are all inherited from the transformer architecture side. But that's a separate thing. I believe you know about this. Um, but the story actually began from December 2017 when Google released this very first model named Transformer, and they also published one of the paper called "Attention is All You Need." So one of the very core component of this transformer model was the attention mechanism that help us to understand the textual data more contextually and more semantically. Then we have a different techniques called reinforcement learning, guys. This is a completely a different kind of learning paradigm, uh, where we talk about the models which learn from a dynamic environment. So it's not that we do some kind of offline training for the model using historical data. So we create a model. Generally, that model is known as agent in this domain, and we push this model into, or we push this agent into a real environment from where it is starting to learn. So when it perform as per the expectations, we give reward to it, and when it perform otherwise, there is a mechanism to put a penalty on the behavior of that model. So why with this reward and penalty mechanism is basically the agent or the model is being trained in a real environment. It try to behave as per the recommendations or as per the expectations of the developers like that. So that is where we see that. And another type of techniques, what we see is the clustering or segmentation. And this is, another type of learning techniques, what you have seen in machine learning. We call this unsupervised learning. And the objective of these techniques is just to uncover the hidden pattern of your data. So we basically talk about pattern recognition or pattern identification under clustering and segmentations. And these techniques are heavily used in customer segmentation or the social media user segmentation. So these are heavily used in these areas on anomaly detection background. So there is as per my understanding goes, guys, and with my experience, there is a very thin line difference when we talk about the use cases handled by um, unsupervised learning or supervised learning. So the supervised learning is mainly deal with label data. Okay, so where your data comes with a proper target variable. So this is where we talk about supervised learning, which is further being classified as a regression or a classification based on your target variable nature. So if your target variable is a real value, we talk about a regression problems like prediction of house price, prediction of sales of a product, prediction of stock price. These are all numerical variable, you know. So these all problems falls in the category of regression problems. Wherever your target variable is something like a categorical variable where it has certain limited categories as an output, then these problems are known as a classification problem. Like email spam prediction, cancer prediction, heart disease prediction, churn predictions. These all problems falls in the category of classification problem. So this is what we call a supervised. Now, when we design a supervised, it is actually a machine learning, I would say that. So machine learning is mostly associated with supervised learning. And there we talk about prediction problem. So when we define the problems, these become prediction problems because you have historical data with input and output pair that you can use to train your model, and then you can use that model to make future prediction for unseen data. But when we talk about unsupervised techniques like clustering or segmentations, this domain is mostly associated with another subject called data mining. So machine learning is mostly associated with supervised learning, whereas the data mining associated with unsupervised learning. Whereas the objective of this is to identify or recognize pattern within a data. Yeah, I'll give you. But I hope you are understanding uh, the objective of clustering and segmentation is to identify or recognize the pattern within a data. So it is more associated with what we call a data mining. Okay, so when we talk about machine learning, we mostly talk about supervised algorithms. When we talk about data mining, we study about unsupervised algorithm like clustering and segmentation. And when we define the problems here, we do not use prediction words. We mostly use detection word. Okay. So like anomaly detection, fraud transaction detection, customer segmentation. We use these kind of words to define our problem. Where when we use a prediction words, this is mostly associated with a supervised type of machine learning base. So one of the question was, can you explain more about regression problems? So regression problems are the problems where your target variable or the predicted variable is of continuous nature, means it is a numerical variable. For example, you can think of a problem where you have different parameter of house, and then you want to predict the price of the house. The price is a numerical variable. Maybe you have, the area of house, number of bedrooms in the house, number of bathrooms in the house, age of the house. Maybe these can be your parameters. And then based on these parameters, you want to make the price prediction of the house. So price is a numerical variable. So this makes this problem is a regression problem. Always remember, if your target variable is a real number, then it makes it as a regression problem. You can think of predicting a price of a car based on certain parameters. Okay, so maybe there are certain input parameters which, the cc of engine, the horsepower of engine, the mileage of a car, like that, and based on that you want to make a prediction of price of a car. So I hope you're understanding like how we define whether a problem is a regression problem or a classification problem. So when your target variable is a real number, it is a regression problem. When your target variable is a categorical, then it makes it as a classification problem. The second question which I see, that the difference between supervised and unsupervised learning. So, like machine learning is mainly classified as supervised and unsupervised. And machine learning, we say the data is a food of machine learning. So if you use a labeled data, that means if you have a dedicated target variable defined in your data, then this comes under the category of supervised learning, which means you already know what you are predicting. You know your target variable, whether you are predicting a price or you are predicting a mileage of a car. The problem is very specifically defined. So that type of data is known as a labeled data. And the techniques that is used to learn from the labeled data is known as a supervised learning. And if your target variable is not specifically defined or it is not present in the data, you only have input features, then this type of machine learning is known as unsupervised learning. And in that case, the objective will completely change. So in case of supervised learning, your objective is to make the correct predictions for the target variable based on your input features. Whereas in unsupervised learning, now your objective has changed to identify and recognize the pattern. So now you are not making any predictions. You basically try to understand if there any pattern exists within a data or not. Now, further, you can utilize that pattern to make predictions. So that is a subsequent stage. But in unsupervised learning, our objective is to identify or recognize any existing pattern within a data, guys. Okay, so we are talking about different kind of techniques that are used over the data modeling. Going forward, with the recent advancement, we talked about some other techniques also within this, like transfer learning. Okay, so transfer learning, here we talk about the models which are already pre-trained, and you can only fine tune these models for your own data. So that kind of techniques is called, transfer learning. Then dimensional reduction, it comes under unsupervised learning, where the objective is to reduce the dimension of your data. As I said, like, originally your raw data may have any number of features. Maybe you have X1, X2, X3, X4, X5, 5 features. But all these features are not necessarily be important for your target variable. Okay, so what you do, you simply try to reduce these dimensions. Maybe you want to drop 2 features, maybe you want to drop 3 features. That is completely based on your analysis or the results of your analysis, what you have done over the data. So you simply want to reduce these dimensions to some lesser number of dimensions. Let's suppose Z1, Z2, Z3. Okay, this techniques called as dimensionality reduction. The objective of this is to simplify your data set complexity by focusing on key features. That means we only try to draw the more important features, the most important features which are highly correlated with the target variable, like that. And the features which are not highly correlated or which are low correlated, you can drop these features for the further study. So this is what we call dimensional reduction. And finally, like an automated machine learning. So these techniques can all be automated by now advanced tool where you can, do automate model selection, automated tuning, automated data modeling, more accessible without any technical expertise. So frameworks like AWS SageMaker, frameworks like AutoML from Google, these frameworks can do this whole job uh, by using some click and drag and drop features. You don't need to write a single line of code for that, guys. It can be done, all automatic now. Now let's talk about some of the use cases where we see the data modeling applications. One is like finance. And in the finance, we always talk about risk modeling. So when I say risk modeling, that means I want to get a model which can help me to assess risk in a financial domain. When I say a risk in the financial domain, that means if I'm talking about loan default, if I talk about credit card fraud transaction, these can be the different use cases, guys. So loan default is like you are issuing a loan to a customer, and that loan will get default after some times. The customer is not able to repay that. So this is what we call loan default. So you want to predict whether the particular customer will be a loan defaulter or not. That's simple. So if the customer is loan defaulter, that means your loan is at risk. Can I say that? Okay. So now you see, this can be one of the use case that we can see in the domain of finance. Now, if you want to do this, the common traditional approach starts from where, like where you start collecting your data. So let's suppose you define your problem as a loan default production. So your problem become a loan default prediction. And what you you want to solve this problem using a traditional way. So you first collect a raw data. So when you go to collect the raw data, you define the entity. So what will be the entity? Entity is going to be a customer or a borrower who is going to apply for the loan. Yeah, I'll come to that. I'll come to that because that is something, Bunny will do that. So you first, you talk about customer and then you try to collect the attribute of the customer. So maybe, you start collecting the different information about the customer. Maybe you can think of customer name, age of the customer, education of the customer, okay, salary of the customer, profession of the customer, okay, the salary is already there. Is he already in depth or not? So whether it is already taking a loan or not. So existing loan or not. Maybe you can think of such parameters. Okay. So you collect this piece of information and then you see whether this particular loan can be issued or not. So if the loan default is predicted as yes, you should not issue that loan or that application should not be approved. If this loan default predicted as no, then you can approve that loan. Now, to build this model, what you have to do, let me talk about that. So, you start with collecting a raw data. So you have collected your data on this. So, based on your historical database where you have many applications already processed application, you have approved many loans, you have this data available for it. And now you have also the targeted variable where you have some examples where the loan went to default and some examples where loan is going smoothly. That means the customer is paying for that. So you have collected some samples from your historical data. Maybe those samples could be 2000 records or 3000 record like that. So now with this data, you can consider all these parameters like customer name, age, education, salary, profession, existing loan. All these parameters can be considered as my input variable, and this lawn default will be my output variable. So based on all these parameters, I have to, you know, decide whether this particular application approved or it should not be approved. That is something. So these become my features. These all become my features. And this is my target variable. Now this problem is a classification problem because my target variable is a categorical variable where I have to predict yes or no. So it's become a classification problem for me, which is given with these features. So the very first thing is like you collect this data. So you have collected some 2000, 3000 samples from your historical database. Then next thing is what you gonna do some data pre-processing. So when you say a data pre-processing, that means you are going to understand the data, you are going to understand the inconsistencies of the data and try to clean those inconsistencies. So, you talk about missing values, you talk about duplicate values, you talk about any kind of inconsistencies exist in the data, and you ultimately clean it. And the objective of this stage is to, make the data more appropriate for modeling like that. After this, you do featureization with EDA. So when I say featureization, that means out of all these features, we have to identify which input features are more relevant to make this prediction. So like here, do you think customer name has anything to do with the lawn default? Any name person can do the defaulter or any name person cannot be a defaulter. Okay, so customer name is not, cannot be a, cannot be a feature to be used. So we can think of dropping this feature and can go with remaining features with that. So this stage is like where we identify out of all given input variables, what variables are important in making the prediction of the target variable. So that's what we call featureization. And then what you do, you start training your model. So that process is called model building. And this model building process has two stages, model training and model validation. So model training is what you do, the data set that you have, let's suppose you have 3000 rows. So out of 3000 rows, you make a split of this data. You can call it as a train data and a test data. Okay, and you can simply let us divide it into an 80-20 ratio. So 80% values will go on to a training set and 20% values will go on to the test set. So like a 2400 records will be on a train set and 600 records will be on a test set. Now using the training data, you train a model. And this data is basically used to understand the pattern, so if what is a appropriate age, education, salary, based on that can we make any prediction or not. So model understand the pattern and it learns from the data, and that is what we call a learning of a model. Once the model training is finished, we can use this test data to make validation. Because we already know the status of the application, whether it was default or not, we use input variables and ask trained model to make prediction whether that particular lawn is a default or no default. And then we can compare with the actual ones. So in that way, you will have a very good understanding about the performance of the model, how well it is predicting the, the records like that. So this stage is called model building. If you find that your model is doing good, it is predicting the values very accurately, then you can think of deploying this model and use it in the scenario. So this is basically the traditional approach, or you can say a classical life cycle of any machine learning project. Now, when you go with the traditional approach, you perform data pre-processing by hand. You need a human expert to do write these code script, identifying the missing values in the records, identifying duplicate values in the records, and then imputing them, removing the inconsistencies. Then look for the next step where it analyze the pattern of the data, understanding the correlation of input variables with the target variable and select the features. Again, a human expertise is required. And then go for selection of a model, training of a model, validation of the model, coming out with the best model and going for the deployment. So all these steps are carried by one manually in a traditional way. But we will see that these all steps can be executed by a GenAI tool like Copilot or ChatGPT or a Julius kind of thing. Very soon we will see that. So what with the introduction of GenAI, a bank uses a GenAI to model credit risk or a loan risk, simulating customer behavior under various economic conditions. So it model and it understand, and the model can be ready in a very quick time, and it performs very well. So we will see that case study very soon, guys. Are we good here? Are we understanding like how the traditional approach and the GenAI approach differs from each other? But ultimately, we are doing the same job, guys. Can I get your thumbs up, or do we have any question here? Okay. And to answer your question, Bani, that how to identify a loan defaulter, is there any formula? So unfortunately, we cannot use any mathematical formula. If there is a mathematical formula, you don't need any machine learning, you don't need any deep learning or Gen AI thing. You can write your conventional program that can, help you to make the prediction. Machine learning, deep learning, AI is only be used when there is a case of uncertainty, when there is a case of noise in the data. And these models are designed in such a way so they can understand that pattern. So that formula is a black box. You can't tell that this is the formula, this is the right formula. So especially when we talk about neural network, this formula is a black box. But somehow this model learns from the data pattern, and it helps you to make predictions. So this is one use case that we can think in a finance domain. Similarly, we can think another use case in retail domain, which talk about demand forecasting model. Okay, so in the retail domain, we always want to, predict what should be the demand of this product in next week or next month or next festive season kind of thing. So again, we can think of, collecting a data from our historical, then cleaning of a data, and it's the whole process we can think. And then we can, design a model that can help you to do the demand forecasting. And that way you can pre-core the inventory before it gets the demand and all. Talking about transportation, so very similarly, like, you can talk about selection of optimized route that help you to reduce fuel cost, that also help you to reduce the overall travel time and all these things. So we can talk about different kind of driving algorithms and modeling with the real ones. Uh, you must have wondered like how the Ola or the Uber or the Google Map um, able to predict that what will be the estimated arrival time, ETA, time of arrival to any destination. You must be wondered with that. So there is a class of machine learning algorithms working behind that help us to make these predictions. And these predictions are pretty much accurate in many cases, guys. If you really not stuck in any jam situation, but these predictions are very accurate. So they collect data in real time, the traffic conditions, the signals and all, and finally they'll able to tell you that what is your app expected time of arrival to the destination is. Have you observed that? Have you experienced it? So with this, let's try to execute one of the case study where we will be, executing this overall data modeling exercise using GenAI tool. And we will be going to utilize Microsoft Copilot that help us to create and analyze data model that is present in Excel, that enabling structured data organization, and it also help us to get insights from the data without need of coding. So what we will do at the end of the day, you are going to write a prompt for it, and then you can start executing that. So you can download the data from your LMS. I hope you have already downloaded that, guys. Please let me know if it is already being there. So just to show you, we have this data set. This data set named as a Superstore sales data set. And you can see that this data set has different columns like row ID, order ID, order date, ship mode, customer ID, customer name, segment of the customer, country, city, state, postal code, region, product ID, category of the product, subcategory of the product, product name, and total sales. So this data has many columns on it. And if you talk about the number of entries in this data, it has around 34 records, I guess, or 35 records. So there are total 35 records that we have in the data. It is a very small data, and because we just use to give you the gist like how we perform data modeling using GenAI tools kind of thing. There is one more document available on LMS that basically help you to execute these stages one by one. Okay, so we will be going to build a data model using Microsoft Copilot. For doing that, very firstly, you have to open the Copilot. Now, I've already executed that, but let me, do it once again for you guys. So let's start from the fresh. Okay. So I hope you all are on the same page. Might be a simple question. Difference between AI or GenAI. Okay. So Bani, the basic difference between AI and GenAI. Basically, GenAI is a part of AI. You can say that. So if this is AI, uh, GenAI is a subset of AI. You can say that. Now see, in a broader term, what is AI? So AI was designed to mimic human intelligence behavior. That's a that's a one-line definition of artificial intelligence. So whatever the capabilities that we human have as an intelligence, we want to mimic that behavior into machines. That is the primary objective of AI. Now, when we say this intelligence behavior, where it is actually helpful. So, like this intelligence behavior is helpful to make decisions. You agree? So we always say that the person who makes better decision, we say he is more intelligent compared to a person who is not making good decision. Can we say that? So this intelligence behavior is very much important for decision making. That's one thing. The second thing, this intelligence behavior is also help us to understand pattern. The pattern that exists within a data, the pattern which exists in our environment, anywhere. So this basically help us to do that. So intelligence behavior is come by identifying the pattern. When you identify the patterns, you can assess future conditions. You can say you can do some future predictions. And if you can do some future predictions, then based on that, you can make better decisions. Do you agree? Just for an example, we know like whenever we see a cloudy pattern in the sky, we can predict that it is going to be a rain soon. So you can take a decisions to carry umbrella. That's the simplest example I generally give when I have to tell you like what is pattern and how we make predictions and how we take decisions. Are you following this? Okay. So this is what this is a human intelligence behavior. But how human learn these things? Because in the past he has seen that whenever there are clouds in the sky, there will be rain. This is something we have learned from our past experiences. That means from the past data. So what we do, we try to talk about all the kind of techniques, all the kind of algorithms and models which help us to accomplish this process. Which process means that help us to understand pattern. When you understand the pattern, that help us to make predictions. And finally, you can convert these predictions into decisions. So now where do we see these patterns? So for this, we generally call the data. Okay, so we talk about all kind of machine learning and deep learning models. These models have capability to learn pattern and make predictions. So, you talk about various algorithms and this all comes under AI. Now the role of AI is to forward that to make a decisions. For example, you talk about spam email filtration or spam email detection. So you get a new email. Okay. You pass that email through a model. That model give you a probability that this particular email is a spam email or not a spam email. So it is doing some kind of prediction for this email. Now, based on the predictions, you can forward this email into a spam box or a spam folder or an inbox. Okay, that is the decision which is taken by the next stage. So that's the overall process. Now, that is what used to be done by the traditional AI. That is what we call a traditional AI. But what happened in December 2017? I was saying like a transformer model was released, and then we started to get, you know, the new dimension of AI, which we are calling a generative AI. So previously, the AI was only limited to do these kind of jobs, making predictions and carry out these decisions. It was not able to generate some new kind of content. So, so if you say that AI can help you to create music, it was not there. If you say that AI can help you to write your cover letter, it was not there. If you say that AI can help you to, create images, it was not there. Because AI was limited for doing predictions, and then converting these predictions into decisions is a next stage process and all this. But this transformer, it was actually designed to accomplish a task of language translation. Think of like that, language translation. So language translation is a kind of task we can think of, where you are giving a one sentence as an input and you are expecting another sentence as an output. Okay, so I'm giving you a very basic understanding here. So it's like, let's suppose we have designed a model. This model is, we are calling it as a transformer model. This model was designed that it takes input in one language. Let's suppose I give a English sentence here, may I eat banana. And now it is translating this into Hindi, मैं केला खाता हूँ. That's it. So this model, it was a neural network model, but it was designed to do language translation job. Okay, we call it as a neural machine translation, NMT, because it is a neural network model. So it is a neural, it is a mathematical model. So it is a machine, and translation is like when you are translating a one language sentence into another language sentence. This is how it goes, guys. So when I say I eat banana, it converts into, this scale. If you see the inner architecture of this transformer model, it came up with two entities. We used to call them encoder and decoder kind of thing. So what you give input sentence to the encoder, okay, it process that input sentence and digest it into a real value vector. We call it as a context vector, guys. Because when you work with the neural network, everything will be represented by real value vectors, tensors, matrices, vectors. This is all going over there. Everything should be represented by number because this is all being done by computer, and computer is a computational device. And with this context vector, it is going to generate a Hindi sentence like मैं केला खाता हूँ. Now, when we see this, the researchers, industry person observed a very good capability of this model, that this part of the transformer is really good at understanding the input. And this part of the transformer is really good at generating the outputs. Can I say that, guys? Because this is generating and this is digesting the input. I hope we are making sense here, guys. Are we good? So from there, they started to go into a new dimensions. If I can generate a Hindi sentence based on English sentence, can I generate something different? Can I instruct, this decoder to generate more than a simple translation? Can I say that, hey, I'm giving you a long text document. Can you generate summary of that? So it will digest it and it is try to, generating the summaries of that. And from there, actually, the story of GenAI started, where we talk about all the models, okay, that can generate content, guys. And these models are mostly inspired from this encoder-decoder architecture because decoder has a capability of generating content. So likewise, we talk about. So that's the basic difference between AI and GenAI. AI is a superset, GenAI is under AI, but it is actually going into a new dimensions where we not limit ourselves of making predictions and, automating things. Now we are in a domain where we can use AI models to generate content for us. That is what we are doing. So we can instruct them. So now let me take you to our case study. So let me log into my Microsoft account and I'm on this page. I have just shown you the data set. So what we're gonna do is we first, we on this page and try to add this data set here. So you can add the file. And I think this is the Superstore data file, which is given to us. So now you have your raw data and we have just seen like what is a classical life cycle of data modeling. So once you upload the data, or you can actually think of pasting a data also. So you can go with either way. You can uh, simply select all these values and just Control C and try to paste it here also. So this way also it is all good. Either way you can try out that. Okay, and now once you load this data, you can think of giving instructions to it. So the very first instruction that you will do once you get your raw data, the very first thing that you check is related to the inconsistency of that. So you can simply write a prompt, hey Copilot, could you check for duplicates in the data and remove them? Simply. So when you hit enter, it is start analyzing this data. So it is like a thanks for sharing the data set, Sandeep. I have reviewed the entities and identified duplicate based on the combination of key field, order ID, product ID, and row ID. Here what I have found. So it will give you the complete summary, guys. Okay. So no exact duplicates found with respect to any of these entities. Okay. Row IDs are unique, which confirms that each line represent a distinct item within an order. And you see, like you have already seen this data. So every entity is unique. Okay. So this way, like you get an confirmation that this data has no duplicate rows into it, guys. Now, similar to that, we can think of asking, hey, can you, a Copilot, could you please check for missing values for each column in the data and tell me? Simple. So I'm simply giving another prompt. So it will check for any kind of missing value present across each of the column. So you see for each of the column, it is looking whether there are any missing value present or not. So here also we are finding that there are no missing values. Even though because this data set is pretty small, you can see that we don't have any kind of missing values available here. Can you see any missing value, guys? That's something we can inspect with our naked eyes as well. The very next thing that you do when you check for any inconsistency, the very next thing that you can do is, you can look for some formatting. So, this data has different columns like row ID, order date, ship and customer ID, customer name, segment, country, city, state. So these columns are different columns. Okay. And some of these columns you can think is a numerical column. Some of these columns are kind of a categorical column. So let us suppose you want to give a proper formatting for them. So I'm giving another prompt to it and I'm copy pasting these prompts from our document, guys. Format all the numerical columns as currency or percentage as appropriate for the column definition. I'm adding one additional instruction here. So when it goes with this, so we found that sales, okay, based on your data set, only column sales contain the numerical values. So sales contain the numerical value. So we can simply format that. So original values are like 261. The formatted values are become $261. And this is actually converting into a USD. Okay, you can write convert into an INR or like that. You can actually instruct it. You can actually prompt it like that. So this is where like you see that we are able to do some initial data pre-processing. We have checked for a duplicacy. We have checked for any missing values present in the data or not. And then we have also transformed our data like that. The next thing is we can again instruct our tool to create a data model from this data, which analyze the sales by reason, product, and time period. So that is where like we want to do some analysis. So sorry. So if you do this, it starts giving you the insights. Okay, so when you go with this kind of a schema, we have row ID, order ID, product ID, customer ID, order date, and all. So it is giving you a total data model schema. So you can have a sales fact table, you can have a reason dimensional table with these many columns over there. You have a product dimensions like a product ID table, and the customer data with the customer ID, customer name, and segment. And then the date dimension also, which date, which year, which month, weekdays kind of thing. So that's how you will be able to decompose your data into different smaller tables, or you can say that. In that way, you get a better chance to make the analysis. So by sales reasons, you can create an aggregate of sales pack, reason wise. Then you can do product categories, you can do sales train over the time by date dimension, and you can do customer segmentation by the customer dimension segment kind of. So in that way, you see, we can think of creating, data models and generating tables out of it, guys. Now, going forward, is it mandatory to use Copilot or any other AI tools? Yeah, Samala, you can use any other AI tool as well. That's all up to you, because these tools are uh, available in pretty much high quantities. You can go for the Cloud A, you can go for the Gemini. All these tools have equal level capabilities. So this is now how we can think of that. And now, let us try to do one more step analysis. So once we have, organized our data in a proper way, now I'm trying to prompt it, Copilot, analyze the data model and summarize the main trends in the sales by reason, by product category. So when you do this, it basically go back to your data and it try to do the analysis over them. So by the reason, you have four reasons like best, south, and central and east. The key observations which are observed by your tool is that in the best region, there is a high sales volume, especially from California city like Los Angeles and San Francisco. From the south region, consistent sales across state like Florida, Texas, Tennessee. From the central region, moderate sales, and for east region, lower overall sales. So while looking this trend, you can easily say that my product is a low sale in the east region, but it is doing very good in the west and south region. So I have to increase, or I have to enhance my sale in these two regions, central and east, guys. Now, when you talk about the product category, again, category wise, if you talk about furniture, office supplies, and technologies, so furniture is giving you the highest revenue generating category. Okay, so it is giving you the highest revenue in overall. Office supplies, most frequent transactions, but lower average sales per item. And technology are the fewer transaction, but high volume items like phone and accessories are being given. Okay. So based on that, like, you are also getting insights from your data, and that is all being done by prompting your GenAI tools, guys. That's that much simple. So based on that, like, you can think of. Now going forward, you can try to get other insights from your data. Like if I say, provide insight on which product have the highest average sales and in which regions. Now you are thinking of that. I want to know the product which is at highest average sale with respect to the region. So if I prompt it like that, it will give me the name of the product with average sales and within the region also. So like it's Chrome Craft Rectangle Conference Table. The average sales of this product is around $1,700, and that is in West California. Then Contel 250 conference phone, charcoal black. Average sale is around $900. That is also best in California. So best is always on the higher sell side, guys. But now you see the analysis and retrieving the insights of data is become so easy when you use these tools like a GenAI tools like that. Let's jump on to a quick check what we discussed till now. So it's a small question. A finance firm wants to make a better data-driven decision about customer spending pattern. How can AI enhanced data modeling help? It help you to handle duplicate data for more detailed analysis. It capture and analyze relationship in customer data. Use only basic detail to reduce complexity, and it avoids structuring data to save time. What do you think, guys? Which is the right option here? So till now we have discussed about use of GenAI in data modeling. Do you think like it help you to duplicate data for more detailed analysis? Do you think it is helpful to create more duplicate data, or do you think it is like capture and analyze relationship in customer data? It help you to analyze the relationship and then give you better insights. What do you think? Option B is the right answer here. Okay. Now, let's talk about how you can use GenAI for forecasting. So we are good with data modeling where we can collect raw data, test about inconsistencies in data like missing values, duplicate values, any kind of inconsistency exist in the data. And even like we can understand the insights from the data. That is something we have seen in previous data. Now it goes for the forecasting using generative AI. That means we can use these models to do predictions for the future incidents, for the future events, and all this. So the forecasting means understanding the hidden patterns, understand the train of historical data, and use these pattern and trains to identify or predict future incidents or future possibilities for that data. One of the examples, like it basically try to harness the data to reveal trends and pattern, and especially the hidden relationship between input and output variable or any type of variable. And based on that, our objective is to identify or make predictions for future incidents. So either we can use for anomaly detection in terms of some outliers and all, or we can improve the predictive accuracy using that, guys. And that is the overall objective of any machine learning or deep learning models, what you study, whether it is from the supervised or unsupervised. In the supervised, we mostly talk about identifying anomalies, identifying outliers, identifying hidden pattern of the data, or in supervised learning, we talk about predictive analytics, improving predictive accuracy and all. So that's what we do in the forecasting. And the objective of forecasting is to make future predictions based on historical data, by analyzing the trends of historical data, by analyzing the pattern of historical data and all. When we talk about the importance of forecasting in data analysis, actually, this is the ultimate thing what we look in the overall process. When you get the data, you analyze the data, you uncover the hidden pattern of the data. What is the use of that pattern? This pattern is actually be used to make predictions in the future. So forecasting is very important in the process of data analysis. It helps you to predict trends that add in a strategic decision making and planning. So when you make right predictions, you can take better decisions. And this is something we have understood with the last example. Uh, if you are making right predictions, you are making right decisions, it always supports sustainable growth through effective resource allocation and all. It optimizes the resources and minimize the waste and inefficiencies. And this is something we can think of a different use cases. You know, for example, let's suppose you are working in a cloud environment, you want to create a load balancing algorithm for different cloud instances. Traditionally, you can go with some handmade resource allocation algorithms which you have studied in your graduation time. The page algorithm, round robin algorithm, first in first out algorithm kind of thing. But nowadays, based on the historical trends, based on the historical patterns, these algorithms can further be improved using some machine learning and deep learning technologies where you can predict the future demand of any particular reason from any particular user, and then accordingly you can preserve those resources for them. So that help us to optimize overall resource allocation as well as it minimize the waste of the resources and inefficiency. Similarly, these models are good at identifying the potential risk and provide a strategic mitigate to that. And that is where we talk about, anomaly detections and all this. So forecasting is very important in the domain of data analytics. There are some popular methods that we generally use to make forecasting, and this is like where we are uh, considering the use case of sequential data, or you can say the time series data, like stock price data kind of thing, or sales data kind of thing. You know, so we can use some time series analysis methods to make predictions. These time series methods analyze the sequential data to identify the pattern and trends and over time. And with the help of that, they basically try to make the future predictions out of it. Uh, some of these methods are based on your statistical approach, like exponential smoothing or ARIMA kind of methods. So these methods are very good at making predictions with the sequential data. So the popular methods for forecasting sequential data can be any of them. Apart that, like we can use conventional machine learning or deep learning models also to make predictions, guys. But for our use case study, we will be focusing on sequential data, or you can say a time series data. So we will be more focusing on discussing these algorithms. Now, in more sophisticated domain, when you compare the traditional forecasting versus GenAI based forecasting, again, you see a lot of advantage with respect to different parameters. For example, if you talk about data requirements, so the traditional forecasting method required the extensive historical or structured data, because these methods are basically work only on a structured data. So you need to convert unstructured data into a structured format, and you need a sufficient number of examples to understand the pattern and train of the data. But GenAI based algorithms can work with both type of data. That means you can use a structured data as well as unstructured data with these models. When you talk about traditional approach modeling, we mostly talk about statistical methods like moving average or ARIMA kind of models, autoregressive models, and all. Where the Gen AI, as you know, these are mostly inspired from more sophisticated AI models like neural networks. So they use neural networks model like transformers to do the forecasting and analyzing the time series data. When it comes to handle complexity, because statistical models are limited with the amount of data and the complexity of the data, so they have limitations when it works with higher complex data, especially having more nonlinearity into that. So you cannot expect a very good accuracy, or you cannot expect a very good predictions with a high complex data using these conventional methods. But these neural network transformer models are really complex model, and they are good enough to understand complex pattern within a data. So you may expect better prediction accuracies over there. Again, adaptability means when there is a sudden shift in the data distribution, these models struggle to adopt it, but these models quickly change the data patterns and easily scale with them. So these are some of the the points on which we can again make a comparison between a traditional forecasting method and Gen AI based forecasting method, and you see Gen AI is a clear vision, uh, clearly a winner in that domain. Um, if you talk about Gen AI techniques for forecastings, the common models that we see in this domain are transformer models, which I just explained you guys. Recurrent neural networks. In short forms, we basically call them RNN. And the advanced version of RNN is known as LSTM or GRU. We call it as a gated recurrent unit and all. And there is another class of neural networks known as GAN, which is a generative addressable networks. And then using these networks, we can also build some sequence to sequence model. And finally, we can combine more than one models to get a hybrid model. So you can always think of combining GAN with recurrent, or you can think of combining traditional models with these sophisticated advanced model. So talking about first transformer, the basic advantage of this model is like attention mechanism. So when you come to understand the power of attention mechanism, it basically help you to capture a long range dependencies. What does it mean is, let me give you a very simple examples. So when you use a sequential data, we generally talk about the sequence of values coming into an order, and then based on that, you want to predict what should be the next value. And I think we human are good at understanding pattern. For example, if I ask you, hey, what will be the next number in this series? All of you will be able to give the answer, guys. What will be the number? What will be the next number? Very good. If I give you another series, let's say 2, 4, 8, 16, 32, and then ask you what will be the next number? And you all will be able to get the answer because you have understood the pattern of historical, and these values are appeared in a sequence. So this is what we call a sequential data or a time series data. Now the text data is also a sequential data. Believe me, like, so when we write a text, we want to write a text according to some grammar rule. So we may expect that what can be the next word in this sequence. This is something is very clear. So if I say I have a sentence like I eat banana, you know, this is the right sentence in English. I cannot write like I banana eat. So, based on the type of words, these words have a specific position in the text. So we can say text is also a sequential kind of a data where the word need to be right in a specific order. You can tell. Now, what is the long range dependency? It is somewhere like when the word is connected to a to the previous word, or the meaning of that word can be inherited from the previous word. Let me give you one example, a very simple example. Let's suppose I have a sentence which says that I born uh, in China. I have completed my school education there, and I can speak fluent. What should be the next word, guys? If I have this sentence, what should be the next word here? I can speak fluent Chinese, or you can say Mandarin. Let's take Chinese. Okay. So you see this word is depend on this word. Let's suppose if I say that I born in Japan and I have completed my school education there and I can speak fluent, then this word is a Japanese. Okay. So you see this word is fully dependent on this word, which is very far in the sentence compared to this distance. And this is what we call a long range dependencies. I hope you are understanding what is the meaning of long range dependency. Because the prediction of this word is purely derived from this word. So if I use German, then it will be Germany. If I use US, then it should be English. If I use any other language, Russia, then it will be Russian. So other words actually do not matter. And in that case, this word has a long range dependency in this sequential order. So you see, Transformer, one of the good feature of Transformer is that they are really good at capturing these long range dependencies in the data. So when you can capture these long range dependencies in the data, you will be really good at making the prediction of the next word. Because if your model is not able to sustain this word to this longer, you might not predict this word correctly. And that is what we talk about there. So these models are really good at capturing the long range dependency. So they can work with more efficiency with the complex data, with complex forecasting, dealing with seasonal and trend patterns and all this stuff. Talking about RNN, as I said, like it is a different type of neural network model. We call it as a recurrent neural network model. And it is also, designed in that way that it can store the memory of previous data, or it can actually store the context of the previous data in the sequence. So it retain the information from past data points and the make predictions based on that. So that's the nature of this particular type of model. Talking about GAN, which is again another type of neural networks, and it is based on two components. We call them generator and discriminator. Generators are basically used to generate synthetic data, and discriminator evaluates the quality of synthetic data against the actual data, and it try to minimize the differences. So discriminator basically evaluate the synthetic data against the real data. And over the period of time, this generator learns to generate more realistic data. That means it is able to make better predictions based on the sequence or the trends received in the previous historical data and all that. Same with sequence to sequence model, as I said, like it is a special kind of architecture designed by a model where you have encoder and decoder kind of units over there. Encoder unit understand the context, understand the pattern of input data, and decoder try to generate the sequence of that. And we call these type of model as a sequence to sequence model. These are some small definitions where we talk about these different kind of models, guys. And finally, talking about hybrid models, where we see you can combine traditional methods with any of these advanced model, and try to get both perceptions. If you have simpler data, you can combine both the models, and you can get the better results out of it. So this is how we can use generative AI techniques for the forecasting. And now, when you go with really with these kind of models, so let me take you to again, um, to one of the case study where we'll try to generate forecastings and we try to generate future trends based on a given data set to us, guys. Let me take you to that this case study, and again you can look for your data set. It is a Microsoft stock data that is given to us. You can find this data again on your LMS, and let me give you the sense of this data. So you see this data is for the Microsoft stock price. On a very first column, we have the dates. It started from 15th of May 2023, like 12th of May, 11th of May, 10th of May, 9th of May, kind of, it's kind of reducing. Here we have a price of the stock, the opening price, the highest, the lowest, and the overall volume. So generally, whenever we study a stock market data, we mostly try to, get this type of information with respect to any stock price. So what we're gonna do is we're gonna actually study this data and try to do some future predictions, like how it will go up, whether you should buy or you should not buy for them. So to conduct this study, we will again go on to our the Julius data Julius AI platform. And again, you have a document available to you that you can use. Unfortunately, I have consumed my limit, so I have run it. So I'll give you a walkthrough, but you can actually work with me, step by step. So the very first thing is that you have to download this data from your LMS. I hope you have already downloaded it, guys. So the next thing is that you need to log into your Julius AI page. Okay. So once you log into your Julius AI environment, you'll see this type of page available here. And all you need to upload your files. So you can click on this plus icon, and that will pop up a window. And from here, you can upload the file. So that's something you can upload it from Microsoft Stocks like that. I have already uploaded this file. Okay. So one by one, like once we upload that, we try to, do some analysis. So once this file is available, okay, we can start prompting it one by one, and we can start first create a data model, and then we try to create a forecasting model out of it. Right? So if you have uploaded that, the very first prompt that you can write is import data from Microsoft Stock.csv. When you upload it, and you can simply, give the prompt like import data from Microsoft Stock.csv. When you do that, it will automatically write a Python script, which you have seen yesterday as well. Like it will first write a Python script, and then it will execute that script that help you to import this data. So, like you are giving a CSV path. If it does not exit, it will return an error. Otherwise, it will load the data into a data frame called Microsoft data frame. MSFTDM. And finally, you try to print them out. So when you do that, you will be able to get it done. Let me try once again if I renewed my credentials here. So what I'm going to do that when I uploaded my data, I'm going to give this simple prompt. Okay, the simple prompt is that import data from CSV. So you can simply, click on this button, and now you see it is actually asking me to upgrade. I'm sorry, but so I've already run this. So you see this data set will be uploaded. And when it is being uploaded, you will be able to see this kind of tabular representation. This is actually indicating the top 5 rows of your data where you have column like date, the price, the open price, high price, low price, and overall volume price. So that's how you get the data loaded over there. The next thing is, you can ask to display the summary and the structure of the data set. So when you say the summary of the data set, like we talk about statistical summary, and that is something you can do by calling the describe method. But as you are going with a GenAI tool, all you need to prompt it correctly. So it will write again a Python script which will investigate the data set structure and generate the summary. So it will investigate the shape of data. It comes with 9,369 rows with 6 columns. The column names are date, price, open, high, low, and volume. The data type across each of the columns are date is an object type, price, open, high, low, volume, all are integer or real type. And finally, if you talk about the missing values with respect to each column, so there are no missing values have been found. And if you say the summary of your data, like a statistical summary, so for with respect to the price, because date has nothing to do with the statistics, it is anyway, it is a object data type variable. So count will tell you the number of values in that particular variable. Mean tell you what is the mean price. Standard deviation talks about the variance across the values. Minimum is 0.09. Q1 or 25 percentile is for the price is 5.37. 50 percentile is 27.09. 75 it's like 43.5, and max is like a 343.11. Now, when you investigate these numbers, it is clear that the mean is way above than median. Can you see that? So 50 percentile is nothing but the median of data. And here you see that the mean is clearly way above than median. So it indicates that this distribution is rightly skewed. It is not a normal distribution. It is a rightly skewed distribution. Similarly, you can investigate the other parameters also for the open, high, low kind of. Next, we try to investigate the data. So we like identify and address any missing data in the data. It has already been done, but again, you can call and you find that there are no missing values into that. So it will investigate your data set. It will look for all the missing values present in that. And if there are missing values, then you can fill that. But we don't see any missing values with respect to any of these columns, guys. Next, what we are writing driving new features such as month, year, and calculate 7-day moving average for close prices. So this price is your close price column. What we are doing here, we are actually manipulating your data set by creating some new columns using date columns. And then we want to calculate a 7-day moving average price. 7-day means the last 7 day, what is the average price, the moving average price. So it's sequentially being increased with a 7-day window into that. So you see, if you go with a coding approach, you have to write this type of code for that. You first need to load the data. You have to select your date column. And now you have to extract the year and month from the date column. And then you are creating a new column called moving average 7 close price, where you are taking the price column and rolling a window of 7 to compute the average of that. Minimum period is 1, like that. So it is kind of, it's become a moving average, and there will be a new column added into there. So you see, originally we have been given with our date column, price column, open column, high column, low column, or volume column. But we have extracted 2 new columns from this date column, the year and the month. So it is not third month in 1986, third month in 1986 like that. And this is how like we are getting a moving average. So this talks about the average of this, and going forward, after 7 days, it starts calculating the moving average kind of values. So you see, with the use of these AI, Gen AI tools, the process of analyzing data has become very easy, and you can analyze a very big data in a quick time. So it's even become very time efficient. Now, let's try to see any pattern. So, what we are prompting the model that you can plot the historical trend on clause prices over the time. So this try to print it, and you see this kind of pattern is exhibited across the year starting from 1998 to 1988 to 2024. So this is actually the trend for Microsoft stock price. You see it starts from a very low, from $0, and it touched to like $350 in the year of like 2021 or so. Then it came down around $250 or less than $250, and now it is again rising with the years. So that's, like you are able to see some kind of trend across the time period. That's how you see that. And this kind of trend one, it is understood by any of the model like Arima or any Gen AI model like Transformer or GAN or RNN, then you can use it for the making of forecasting. But as we are going with the Gen AI approach, we can think of now model building process. So if you remember, the next step in the model building process, once you analyze the pattern, you start splitting a data. So we are prompting it like to make a split of data into 70-30 ratio, where like you can, divide the data into two parts, training and test. The training is 70% observation and test is 30% observation. Remember, this is a time series data, so it should not be split randomly. Okay, because if you try to split it randomly, it doesn't make any sense. So you have to divide your data um, specifically to have 70% historical and then the remaining 30% in the future for them. So we get two subsets. We call them training and test. And finally, we will be able to get our training data and the test data. So 70% data are in training and 30% are in test. And you see, like these are kind of a sequential we are getting here. Now over this, we can start our model building process. So we can again prompt the model that build and train a forecasting model using training data to predict future close prices. Now, when you prompt it like that, we are not specifying any models. We are not telling whether you have to implement ARIMA model or any traditional statistical model or any machine learning model like linear regression or XGBoost model or random forest model. We are not saying that. So this is something, it can be decided by model itself, because if you are not specifically telling it, it automatically go with one of that. And if you see this particular code, it is actually trying to implement this ARIMA. I hope you are able to see that, guys. So it will actually create an ARIMA model and then it try to make the predictions. So you see like by trend, it's going like this way, and then it's making predictions. So these two lines that you can see in the form of red or that you can see in the form of orange, this is like you are getting the predictions done by different models. Like blue is actually hidden because of the other color. So it has implemented three models like ARIMA, naive Bayes, and gradient boosting regression. So ARIMA is giving you a flat line, which means it is obviously not a good model to make such complex data predictions. Gradient boosting is somehow it is, going along for some reason, but after that it left behind. But the naive is actually making very good approximations with these blue lines. And even though if you want to see the forecasting, that's how you see the forecasted values for different horizons. I hope we are making sense here. So the overall model building process can also be automated using these GenAI tools. So this is how we can think of forecasting, building a forecasting model using data and all. Now, let's talk about a quick recap. question, and then we'll talk about some of the challenges, practical challenges, like when you try to integrate GenAI into data analytics. So, which of the following is a popular forecasting model used in data analysis? Time series analysis, exponential growth, logistic regression, or K-means clustering rates? What do you think? What is the right option for this? What we have seen just, was that a time series or exponential growth or a logistic regression or K-means? So yeah, so this is the most popular forecasting model that is used in data analysis, especially when we talk about sequential data. Now let's talk about some practical challenges that you see when you try to integrate GenAI in the process of data analytics and all. So some of the key challenges which we address in the form of that you have to ensure the reliability and the performance of the model. That's very important, and this is important in every aspect of machine learning model or deep learning model. So whenever you build a model for any use case and you deploy it, that's your duty to ensure that the model works efficiently and accurately across the time loop. Uh, with the Gen AI, it comes with a lot of power, a lot of complexity, a lot of load, and all these things. So when it has a lot of power and a lot of complexity, this model can be exploited to, perform different tasks. So while using them, you have to be very ethical and responsible while implementing these models. And this is very important when we talk about GenAI. And it's not my experience, and what I can see is very soon you will start seeing one more role um, in industry for AI is AI ethic officer kind of thing. So, we talk about sustainable AI, we talk about ethical AI, we talk about responsible AI. So we need a kind of role which ensure the application of AI in your domain, that this application is ethically or it's with full responsibilities. Like we are not exploiting any rule, we are not making any false claim or like that. So that's very important, and this is something we are all hearing from across, that we want to use AI ethically and responsibly. Um, this encourages to have a continuous improvement and adaptability. Obviously, data is changing and it is changing as at a very rapid rate. So you see there is a data drift. The distribution is changing. So you need to keep on developing adaptable model with continuous improvement and all. There are certain technical constraints, when you include or introduce GenAI. We will talk about them also. So you have to address them properly. Uh, Facilitate collaboration and cross-functional integration. That is one of the advantage, but that is again when you work with different teams, and integration become always a challenge for that. It to reduce risk and prevent potential failures. This is one of the advantages. Again, like when you go with these advantages, you are going to face certain other challenges compared to a traditional method. So let's understand them one by one. The very first thing is that you have to maintain data quality and availability. So when you talk about these GenAI integration to your data models, or when you talk about the GenAI integration in the forecasting, the data quality and availability is very big issue. You need to generate or you need to pass the qualitative data continuously to your model, because if that quality deviates from the standards, the results or the predictions of models falls very rapidly. The thing is, like, these models are not trained, actually they are trained on a different sort of data, but they see the instance of data and based on that they make predictions. The traditional approach, what happens, you train a model that become very robust to the distribution of a data, and then it is only designed to make such kind of predictions, like uh, Arima model or Sarima kind of model. But when you use tool like, Julius, or when you use a tool like Copilot, there is a variations that come. So when you give a new data, they make prediction according to the distribution of the new data. But if the new data is not a qualitative data, or it's come up with some redundancy or some inconsistency, then it may train a wrong model that mislead the results, guys. So that's one thing. The second is the data privacy and security. So as I said, like when you use these models, generally you process a lot of information with them, and sometimes that information can be digested by these models. And most of these models, because of their complexity, are accessed through API request. So it's not that you can host these models onto your local device or in local environment. So most of the cases you don't want to share your personal business information to the third party, but you need to ensure that as well. So when you go for the integration, you need to take these challenges while considering these models, right? The next is model complexity and interpretability. Like these models are very huge in size, so you can say like these models are very complex, and this complexity leads to a big size, and that big size leads for a big resource requirement that we will also see. So you can't use these model on your local devices or local environment. So you require a significant computational resources going forward. And talking about interpretability, because these models are very complex, so it is always a black box kind of thing, where you give input and you give output, but you don't know that how these inputs are being transformed into the output. So that function fx is not very known. This is like the same thing, Bani, you raised, like, is there any formula? Definitely there is a formula, but this formula is not very much interpretable. So we don't understand like what is that formula and how this model is able to map the input into the output. So that's what the question. So these models, because of their complexity, because of their big size, they are less interpretable. So they are less transparent also, guys. Then scalability and deployment issue, as I said, like these models are very large in size in terms of number of parameters. They are really very large, so they required the good amount of resources to be there for hosting. Like you need a good GPU and TPU supports, and if you are talking about scaling, even you required more number of resources for that. So that is always a challenge. Ethical and bias consideration. And nowadays we are hearing a lot of buzz around this word bias. So the data that was used to train these models, we know the data comes with its own biasness, guys. We can't expect that data is pure, it has no biases. But if you use a biased data to train a model, your model become little bit biased towards also. So it is a duty of the trainer or the builder of a model that it should remove all the biases from the data. But in some cases, it is not possible, especially in the case of health sector or a finance sector. You never expect to get a very balanced data across different parameters or different domains. So when you go with a bias training data, your generated model will also comes with a bias. And when it use that bias to generate the predictions, the generated predictions also comes with that bias, and sometimes they produce some inaccurate outcomes as well, guys. Next is the potential for misuse. As I already said, like these models have literally a tremendous capabilities, and if you can use them in right direction with the right prompt, you can expect to compute any kind of job with them. All you need to understand the functionality of the model and then instructing in a right way. With this real power, these models can also be misused to extract different information, stealing information, generating fake content. So nowadays you are seeing a lot about fake videos and all. Have you seen that, guys? So this is where, like, there are a lot of challenges. Then human and organization factor. This is again a challenge. Currently, our workforce is not ready to work with these models, and we are seeing like there is definite gap in terms of the skill to understand these models and use of these models. So that is where we talk about a skill gap. And at the same time, the most of the organization are bit hesitate to use them also because due to the complexity of these models and the size of these models, they cannot host these models to their own premises. And at the same times, the organizations are not ready to share their data to third party. So there is a kind of resistance is also being shown by some of the organizations to shift their operations from a traditional approaches to GenAI approaches. So this is more onto a common challenge, okay, not a technical challenge, I would say that. Again, like security and intellectual property, this is again related, like sharing your personal and PII information, because you can't say that the model that you are using to make predictions, to make analysis, whether it is fully secured or it cannot be accessed by any unauthorized users and like that. So it is always being there. Like, so these are some of the challenges when we talk about integrating Gen AI data modeling and forecasting. Uh, Now, how you can evaluate any Gen AI model performance, guys? So this is very important because when we talk about conventional machine learning models, we generally use them to compute regression or classification problems, and we have a very standard matrix for them. So in case of regressions, we talk about mean absolute error, R square scores, or root mean square errors. Or in terms of classification, we talk about accuracy, precision records. We have a standard matrix. And because the problem is very straightforward, you are making predictions for either a number or a category, it is very easy to validate also. But when we talk about generating of content, analyzing of content, the domain become very wide and diverse also. So when it comes to evaluate any GenAI model, we actually look three major aspects, and these three major aspects are being evaluated in three different ways. The very first thing is like accuracy. So when a model is generating content, how much accurate it is. So based on the type of use case, we can use different predefined evaluation metrics. For example, if we are using a model for making classification prediction, we can use the F1 score or precision or recall kind of metrics for doing that. If we are making use of this model for text generation, then we can go with the metrics like blue or row for accuracy and the relevancy of the generated text for that. So in that way, like we can assess the accuracy of the model, that how well it is good at generating the content, or how well it is good at predicting the value for any particular variable. With that, we can also have some qualitative metrics, okay, that talks about creativity and alignment of the content. So like the same line can be written in multiple ways, but the context remain the same. So when you try to judge the creativity of the model, we can have some qualitative metrics also. So contextually, we can say that the sentence has the same meaning, but it is being articulated in different manner, and that's what we call a qualitative. The next thing is relevance. So again, like it has become a task specific metrics. So if it is a task specific, then we can think of our conventional metrics like precision recall and other. And on the qualitative type, we can look for human evaluation, like how the content is aligning with the actual data. And again, here we talk about the relevancy of the generated text with the actual text. So if they are relevant, then we say it is relevance. Otherwise, it's not relevant kind of. And defining some creativity and originality of the text. So when you train these models are trained on a large corpus of text data. So definitely they come with two major characteristics, that they are really good at understanding the textual data, as well as they are really good at articulating the generated text. Means the text which is generated by these models is grammatically very accurate, and it can written on very high level of comprehension, you can say that. So right comprehension is there, reading comprehension is there. The problem is the facts, whether the answer is factually correct or not. So accuracy should be measured or relevancy should be measured, but at the same time we also look whether this model is good enough to introduce creativity into that. So if you say that explain AI for a 5-year-old kid or explain AI for a 50-year-old man, it should be able to generate different text for that by understanding the audience. And that is where we talk about creativity of the model. But it should keep the originality also. It should not change the definition of the context of the AI, I believe. Understand? So, so we have seen the challenges when we integrate GenAI for data modeling and forecasting. And we have also seen that if you have implemented any GenAI model, how you can evaluate it. So based on three parameters like accuracy, relevance, and creativity. Now let's talk about some of the common strategies for integrating GenAI into data analytics. So now I think we have a very good understanding of for the data analytics process. It starts with collecting of data, pre-processing of data, analyzing of a data, and doing a forecasting for that. So going with that, if you really look for integrating generative AI in the process of data analytics, it start with a data preparation where we have to ensure that the high quality and diverse data to be introduced to these models with minimized bias. So your input data should not come with any kind of bias. That way you can help to improve the model. So to do that, you apply data cleaning, data augmentation techniques. This is something we discussed yesterday as well, like how you can, augment and create synthetic data and all this. After that, once you are ready with the data, you have pre-processed the data, then you can, try to apply different models, like we have seen in our previous case study, where the model try to implement ARIMA model or the gradient boost model, and then it compares like which model is the best on that. So we basically select an appropriate generative model, and that way it also help you to get the right model as an output. And this is an optional thing, whether you need an interpretability or explainability in your use case or not. If you required an explainability or interpretability in your model, you definitely go to with a model that is highly interpretable as compared to a complex model. In that way, you may experience a little reduction in the accuracy, but you get interpretability on the other end. So the model which is highly interpretable may not be able to handle a complex data. The complex data is actually handled by a complex model, but complex models are generally a black box model and comes with a less interpretability or explainability to them. Next, come to the integration. So we can integrate generative models seamlessly into any existing data analysis pipeline. We have seen like how you can use GenAI for creating automatic ETL process, then automatic data pre-processing, then creating forecasting. So we can all create that. And for doing that, we can use any suitable API frameworks that enable a smooth interaction with other tools. So it can collect data through multiple sources and process them through a pipeline. The evaluation and monitoring is again a challenge. Like you have to define your metrics very clearly, okay, and that can help you to assess and uh, you know fairly judge your model for the generated data. Okay, so the overall process flow will go in this way, guys. So you start with integrating GenAI as a data pipeline. So you collect your raw data, go with data cleaning and transformation, and apply feature engineering, the model integration, which is a selection of forecasting model, and finally you get an output and visualization for monitoring and all this. So overall, Gen AI into a data pipelines are being defined by these many steps, guys. And I think these steps are self-explanatory. Please let me know if you are not clear with any of these steps, because this is something we have discussed in very detail in our case studies as well, guys. So, what is the future path? So we are concluding. Uh, we are concluding the GenAI use cases in data analytics. We have understood the process of data analytics. It is all about analyzing the data, uh, uncover the hidden pattern of the data, uh, understanding the pattern and train of the data, and then making a forecasting model for data-driven decisions. So this is the overall objective of data analytics. And we have seen the role of GenAI of performing each of these steps one by one. So where the future is going and where the future trend is going, that if we understand that, I think we can make ourselves ready for the future. So currently, when you see the future trajectory for the emerging trend of GenAI for data analytics, we can highlight these five main points. We are basically focusing on improving our data augmentation techniques. So we can generate better data, or we can augment existing data in a better way for data analytics. That augmented data mimic the real data in terms of its distribution, in terms of its characteristics. So we still wants to, improve in that state. Then second is we are also looking to personalizing the data exploration and generated tailored insights. So currently, what is happening? Like when we perform any analysis, it is not data centric. It's not a point centric. But if you want to make a point centric, it become more personalized data exploration kind of thing. In that way, we can think of solving use cases which are related to the customer segmentation or social networking website like that, where we try to understand the characteristics of the customer, and accordingly we try to feed personalized recommendations to him, or we try to give insights at a personal level. So this is again, like we see that we are advancing generative pre-training for more efficient AI models. So this is the open field, and we are seeing a lot of new models are coming into the market. If you ask me the current state, I think more than 20 lakh GenAI models exist in today's world, and these models are increasing on every week. So every day we see a new model. That model might be a general purpose model, or maybe a specific model like work in a speech domain or a text domain, or an image domain kind of thing. But every day we are seeing that new models are coming into the market. Next is we basically want to conduct a counterfactual analysis for robust decision making. And this is also a very important domain which is recently gaining popularity. So whenever we talk about any LLM, these LLM are designed in such a way that you give an input, this always going to give an output, whether this output is correct or not. Now, when this output is incorrect, this situation is what we call a hallucination. That means this LLM is trying to mug up the answers. It is not factually correct, it is not relevant, but it try to mug up that. So that stage is called an hallucination. So sometimes these LLMs fails to provide right answers for your queries. And if that happens, we want to find out those points where these models are failing. This behavior we call stump. So we basically try to stump the model for any question. And the companies are collecting that data where these models are failing, so they can use that data to retrain that model. And that is where we are saying, like, we basically conducting a counterfactual analysis, whether that particular answer is correct or not. If it is not a correct, then we force the model to make this correct to make a more robust decision making, guys. And finally, we because these models are complex, these models are huge, so we are in the hunt of getting more explainable or interpretable models. So if any model is predicting anything, at least we have an explanation for that, so we can understand the relationship between input and output variables for a better analysis of that case. So with this, now let's have a quick check with this small question. Which of the following is a recommended approach for ensuring ethical data analytics when using generative AI? The first option is ignoring data quality and diversity, neglecting privacy preserving techniques, avoiding transparency and explainability, and emphasizing data quality and diversity, guys. What do you think? What is the right option? When it comes to ensure ethical data analytics, we want to emphasize more on data quality and diversity. Now let's talk about one of the case study, which is heavily used, heavily using Gen AI, and this is like ESPN. So we all know about ESPN platform. This platform is a place where we can get the information of different sports, what is happening across the globe, with how many matches are playing, like what are the score of these matches, like that. So to sustain this level of information is a very tough ask. Okay. And when you talk about the different challenges of this platform, you can think of this high demand for scalable content creation is there. Okay. And especially in today's time where you see in any part of the world a match is going on. So you need to be very updated with your content over there. And when you have such level of pressure where every minute there's game playing in any corner of this world. So you need to update with that, and you also need to update your customers or the client or your readers, blog readers, and all that. So time and resource constraint is also being there. Like you need a lot of people to address these games. You need to update with this information and write the content for them. And with that, the complexity of data is also, there because every viewer is looking for a very detailed analysis with respect to the game. Like if there's any cricket match is playing, that you want to get a detail by ball, where we talk about these commentaries and all these things, guys. So this is a very challenging domain, especially in today's world where at one time I think more than 10, 12 different games are playing. If you even focus on a cricket game, then you see like, so how to being an updated? So this ESPN is try to address these challenges using GenAI, where it talks about automated content generation, and then there is a content review workflow. So this content is actually being generated by these GenAI tools, and then it is being reviewed by some human reviewers. So any faults and the wrong content should not be pushed onto the platform like that. So yeah, GenAI has become the part of ESPN kind of platform now, and it is heavily using that. So in that way, ESPN is benefiting on many dimensions. Like it is enhancing the scalability. That means at the same times it is able to cover, many games at a time. It saves a lot of time when it comes to write the detailed summary about the game or give you a ball by ball analysis and all that. It become very cost efficient also. You don't need to hire too many people to write these stories and analysis. And when people are getting more detailed information, it improved the customer engagement or the fan engagement or whatever, guys. So in all way, the use of GenAI on a platform like ESPN is always a win-win situation for that, and that's how we see, guys. Now let's talk about our guided project. And before that, I would like to talk about our key takeaways for today's session. Um, and please let me know if you are not clear with any of these takeaways. So the very first is, are we or can we say that the Gen AI enhances data modeling by increasing efficiency, precision, and adaptability is clear to all of us? Can we say that, yeah, with the use of Gen AI, you can increase efficiency and precision and adaptability in the data modeling space? Are we all agree with that point, guys? Or do we have any confusion regarding this point? The second is the AI-driven data modeling benefit industries like finance, retail, and transportation supporting data-driven decisions. Are we clear with that? That how these techniques are supporting these industries to make better data-driven decisions? Can we explain the use cases from these domain where we can talk about application of Gen AI to make better data-driven decisions? Do we have understanding where we say techniques like transformer improve forecasting by capturing complex and long-term data patterns? Do we understand that how the transformer solve the problem of capturing a long-term data pattern or long-range dependencies? Yeah. Do we understand the integration of GenAI into data model process poses some challenges, such as data quality issue, high computational demand, and maintaining ethical standards? Do we understand that aspect as well? Like, so when you use GenAI into data modeling, you need to keep your data qualitative data. It should not come with bias. You need a high computational demand because these tools are, the complex, high in size, require a lot of resources to compute. And finally, can we say that the performance metrics like F1 score, employing strategies such as continuous monitoring ensure reliable and effective model output. So if we are using forecasting, we can use that. And we see any deviation here, that something is alarming to us, and we can say, we are deviating from actual performance. Can we say that? Yeah. So with this, Key takeaways, let me take you back to our guided project. So in this particular guided project, we basically try to learn that how you can apply generative AI tool to clean, pre-process data and build forecasting model for retail sales. By completing these tasks, learner will gain hands-on experience using AI tool to enhance data modeling and forecasting accuracy. I request you to download the solution document and reference material sections. Okay. So I can simply highlight that for you. So when you see your LMS, you will be able to get this document. Again, that talks about data modeling, forecasting, and practical challenges with one of the data set given in the form of CSV file where you have these seven records across these five six columns like date, product A sale, product B sale, product C sale, advertisement spend, and finally the customer segment sentiment, whether it is a positive, neutral, and kind of segment is given. So this is a very small data set, but we will be going through a one guided project here. So you see that by looking this data, one thing is clear that this data has some missing data points into it. Can I say that, guys? So we will basically carry out a process where we will load this data, clean this data, then uh, you know pre-process this data and build and forecasting model using that. So you must have now received this document, which I am showing to you. I hope my screen is visible, guys. Can you see this document? Okay, so you have been given with certain instructions. You have to work through all the question individually within our group. So either you can take it individually because it's not a big project, big task, and then you will be going to utilize this document to perform the task. So what is the task? You have been given with one scenario that a retail chain plan to expand into new market and needs accurate sales forecast to allocate resource effectively. That means you have to build a sales forecasting model. Now, by analyzing historical sales data, advertisement spending, and customer sentiment, learners will build a predictive model to anticipate future trend, identify potential challenges, and refine strategies for market entry success. So this is something what we have to uh, generate as an output, as an story of that. For solving this task, we will be going to use GenAI tools and we will be using Microsoft Copilot. So again, a very simple way, you have to log on to a Microsoft Copilot. And very first thing is that what you do, you need to upload the data set. The very same exercise is what we did, guys. Are you able to carry it? Okay, so the very first thing that you have to sign into your Microsoft Copilot, and next is to upload your data. Then you have to write a prompt that basically clean and pre-process the data set. So when I say clean and pre-process the data set, that means you need to validate all the columns with appropriate definitions. You have to impute the missing values with appropriate numbers and all that. Once you are ready with the data, once you finish with the data pre-processing, you can instruct your model to create a forecasting model for sales. Okay. And the very first model that you forecast is based on the simple sales trend data. Then you make another model that incorporates sentiment analysis. So, like in the data, we have been given with one more column that is a sentiment of the customer. You see the positive, negative, neutral kind of this. So we would like to introduce that particular parameter also. And this is where like you can say, uh, think of a model that can take different types of informations to make better forecasting. So going forward, you have to incorporate the sentiment analysis parameter. Then you see whether there is any challenges in evaluating the model. Okay. And finally, you propose the solution for practical challenges for that, and you document and present all of your findings. So this document has a very detailed steps one by one. And this document is also available on your LMS portal, guys. I request you to please execute these steps and see whether you are able to follow these steps one by one or not. In that way, you get a full hands-on experience of executing data analytics project using GenAI tools. Okay. Are you compiling these steps? Going to copilot.microsoft.com, signing to the Microsoft account, uploading to the data, and then either you can paste or you can upload. Any way you can do it. Then you can simply prompt it, identify missing values in the data set and list the affected columns. So when you do this, the GenAI Copilot tool will identify all the missing values and it try to address them accordingly. Then you can replace the missing values with an appropriate number. So you get this kind of explanation. Maybe this document is a bit load, so the new Copilot will give you a different sort of description, but overall, like you get this kind of explanation for each of these steps. Finally, when you impute your data set, you will be getting this type of data where every column is filled with numbers. So there are no missing numbers here. Okay, then you can normalize your data. Normalization is like converting into a uniform scale to every column values. In that way, we can think of giving an equal weightage for every column value. So you can do it by prompting. You don't need to write any code for that. You can simply do it the prompting that normalize the sales and advertisement spend column to scale that. After that, you can think of creating a forecast model. So now you can define any time series model forecasting methods like ARIMA or any other. So you can, make a prediction for next 3 months sales for product A, B, and C. That way, this model is being created internally, and that will actually project the predicted sales for the next coming month, month one, month two, month three. Okay. And then you see we can integrate the customer sentiment into that. So build a regression model to forecast sale using advertisement spend and customer sentiment as a predictor. So when you introduce these two new parameters, you get a different output and then you can fit a model for forecasting. Going forward, you can talk about incorporating of sentiment, analyzing of sentiment based on that. And again, all of these tasks are actually being done by writing a simple prompt. So analyzing the customer sentiment column to calculate the proportion of positive, neutral, and negative sentiments on that. And again, like adjusting the sales forecast based on sentiment trends. So that's you adjust the forecast based on the sentiment. If the sentiment is negative, you can reduce the sales demand. If sentiment is positive, accordingly, you can increase. So in that way, you can go step by step, and finally, you can even ask your model to write your, findings and conclusion of this overall study also.
And with that, we have reached the end of the session on generative AI for data analytics and how AI is changing in data analysis. So today, we saw how generative AI can support almost every stage of the analytics workflow, from preparing and transforming data to exploratory analysis, visualization, modeling, forecasting, and communicating insights. We also understood that the biggest change is not simply automation. The bigger change is that analysts can increasingly move from a business question to analytical exploration much faster by combining natural language AI with traditional analytics tools. But the most important takeaway is that AI does not replace analytical thinking. Reliable data still matters, the right metrics still matters, business context still matters, and validation also matters. The strongest analysts will be professionals who understand the data, understand the business problem, know how analytical methods work, and know how to use AI to make overall workflow faster and more effective. So the future of analytics is about combining data skills plus, I repeat, data skills plus business understanding plus analytical thinking plus AI capability. So if you have any doubts or queries, let us know in the comment section below, and our team of experts will be happy to help you as soon as possible. Thank you for watching and keep learning.